Hi everyone, welcome to Vedantu NEET English. I'm Diksha, your chemistry master teacher. I hope you all are doing good. And students, as we are doing GOC, so till now we have completed all the concepts of GOC and now we are left with isomerism. And in isomerism, usually students find it very difficult because there are so many concepts included like RS, DL configuration. So we will cover all the topics today itself. Okay, so are you all ready for today's lecture? Today we are going to complete structural as well as stereoisomerism. Everything we are going to complete today. So are you all ready? Everyone join in. Everyone join in the session so that we can start this session. Okay. Okay, so let us wait. Let us wait. Okay. Just yes. So, bacha, in isomerism, as you all know, we are going to complete structural as well as stereoisomerism. Even structural isomerism has so many parts into this. Like tautomerism comes under structural isomerism only, and you all know that in all the reaction, in most of the reaction, you can go through the PYQs, you can analyze your PYQs, you can see that tautomerism have been asked in so many reactions. And then if we go to stereoisomerism, bimolecules basically and haloethane, haloarenes, everything, that inversion, retention, all is stereoisomerism. So we will complete all of that today itself. In stereoisomerism, we have geometrical isomerism, cis trans, EZ, anti-syn, everything. And then after that, we have optical isomerism. In optical isomerism, we have enantiomer, distereomers, RS configuration, DL configuration, epimers, enamers, everything we are going to complete today itself. So today's session is going to be a very important session from your NEET point of view. Very, very important session. Okay. So guys, as well as boards point of view, because also in boards also these questions are directly asked. Okay. So now all the question, all the PDFs that we are doing here, all the homework, everything will be provided in the Telegram. You can see weekly schedule, daily quizzes, weekly mock tests, the analysis of weekly mock tests, and also now we have an option of comments also. You can ask your doubts in the comment section, right? So here will be an option of leave a comment. So you can write down your comment and we will reply to you. Okay, so in that way you can interact with us any time of the day, right? You just need to operate this thing, that is leave a comment, right? So we all want that you should interact with us on a daily basis, wherever you want that. Okay, ma'am, I have a doubt. You just need to leave a comment and we will answer you. Okay, guys, shall we start? Shall we start? Everyone in the comment section, shall we start the session? Right? Today is going to be something that all the students usually skip. Okay, we are so afraid of isomerism, let's skip this topic. But you should not skip this topic, as this is a very, very important topic. And so many chapters, this has been asked, okay? If they have given a structure and they'll ask which isomerism is there. Is this cis, trans, geometrical, whatever, okay? So many questions will be asked from here. Okay, so shall we start? We will start from a very basic thing. Basic thing as in what is the definition of isomerism? What is isomerism? Then jumping towards structural, then stereo, then RS, DL, epimers, enamers, everything. Okay, so let us start. Firstly, what is isomerism? What is isomer? Isomer, as you all from the very start in small classes you have studied this. Isomerism is basically when you have same molecular formula. They are the same, number of atoms are same, but the arrangement of atoms are different. Like as you can see, if you have this C3H6O2. Now this particular formula can have 2-3 structures. So that means it has same molecular formula, but it will have different structural formula. Okay? Okay, everyone? I think something happened here. Something happened to this board. And now about isomerism. Now, beta, we have two types of main isomerism. First is structural isomerism and second is stereoisomerism. What is structural isomerism? Let us, anyone in the comment section, what is structural isomerism? So talking about structural isomerism, as you all know, Like we have 3-4 atoms. Now, if the linkage is same, if the linkage is different, that is called structural isomerism, right? If I'm talking about my body, I can't separate this head from my body. I can't separate these arms from my body. That means I can only change the spatial arrangement. That is stereoisomerism. So structural isomerism is basically when we buy a doll, what we do, we can just take out the arm of that doll or head of that doll, that we used to do in when we were kids, right? So we can take out the head of that doll, but we can't do that with ourselves, right? So that doll is basically structural isomerism and you are stereoisomerism. But you cannot take your head, right? But you can rotate your head. That means you can change your spatial arrangement. So changing your spatial arrangement is stereoisomerism, and changing the linkage, that is called structural isomerism. You can recall it by the doll example is structural isomerism, and we are in the stereoisomerism. Okay, perfect, perfect. Now let us discuss structural isomerism firstly. What is structural isomerism? There are so many types of structural isomerism. First is chain isomerism, then position isomerism, functional group isomerism, ring chain isomerism, metamers, and then tautomerism. Most important isomerism that will be asked in the questions. Okay, that is sure you will get some question from this topic, tautomerism. Right? So these are very simple. We'll one by one we will take an example of all these isomerism, and we'll see what is actually with the help of examples we will see what do you mean by these isomerism. Okay. So first is chain isomerism. As the name says, chain is the parent chain is different. Right? So chain isomerism means the parent chain will be different. Baki, the molecular formula is same. In every isomerism, you will write molecular formula same, molecular formula same. So now, predicting this from the chain itself, chain means the parent chain will be different. Right? So let us take this example. This is A, this is B, and this is C. So as you can see, from IUPAC naming, you can clearly predict. Now we have 1, 2, 3, 4, 5. This in the parent chain has 5 number of carbon. Firstly, predict the longest chain, longest parent chain. Okay, then see if there is difference of parent chain, right? So now here we have longest parent chain is 1, 2, 3, 4. That means the parent chain is of 4 carbons, and here the parent chain is of 1, 2, 3 carbons. That means there is difference of parent chain. So this is a chain isomerism. Very simple. You just need to understand what is the longest chain, longest parent chain. If there is difference in the parent chain, that means it is a chain isomerism. Right? Okay, everyone. So now let us see next. Position isomerism. Position. What is position isomerism? Position isomerism is when you have same molecular formula, we know that now. Okay, same parent chain. There will not be difference in the parent chain, but there will be difference in the position of substituents. There will be difference in the position of substituents. Okay, the different position of branches or functional groups. Substituents can be functional groups, or you can say branches that are substituents, right? There will be difference in the position, the numbering of that. Okay, so now let us see. This is the first example and this is the second example. Okay, so let us see. Let us firstly identify the parent chain here. So this is OH. So identifying the parent chain, this will be 1, 2, 3. And here it will be 1, 2, 3. That means parent chain has same number of carbon. There is difference of OH group. There is difference of the position of OH group. In this particular case, OH group is on the first position. And in this case, OH group is on the second position. That means there is difference of the position of branching or function group or whatever there is written. So here it is a position isomer. Right? Perfect. Possible? Yes. Positionally changed in substituents. Perfect. So now let us see another example. We will see lots of examples today. Lots of examples today. And I am telling you, if you are doing this lecture, you don't need to see any other lecture. You don't need to refer to any book. Already I have referred to so many books, and this is a combination of so many books that is in this lecture. So this lecture is enough for your isomerism. Okay. So now this is A and this is B. So let us see the position. This is 1, 2, 3, 4, 5, 6. And this is 1, 2, 3, 4, 5, 6. The longest chain here is same, like of 6 carbon atoms. So there is same parent chain, but the position of second chloroatom, right, that is different. Okay. It is in the second position and this is in the third position, right? So there is position isomerism present here, right? So here is position isomerism present. So now let us see how many of you can answer this. How many of you can answer this? Let us see. Always remember, I have told you that firstly, always mark the longest chain according to IUPAC rules. According to IUPAC rule, firstly mark the longest chain here. What will be the longest chain? Everybody in the chat box. Are these position isomers or not? Are these position isomers or not? Let us see. Let us find out. Okay. So as you all know, COH, carboxylic acid group, or any group that is carbon containing. So that is those kind of groups that the numbering starts from them always, right? In case of alcohol, the numbering does not start from alcohol. We just need to give the minimum position, minimum numbering to alcohol group. But in case of COH, the numbering starts from COH. Okay. So this is 1, 2, 3, 4. 1, 2, 3, 4. That means here the longest chain is this. Right? The longest chain is this. And in this case, numbering will start from this carbon. 1, 2, 3, 4, 5. So, what you just saw, we thought these are position isomers. Okay, we considered 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. There is change in the position of COH group, ma'am. This is position isomer. But actually, it is not position isomer. There is difference of chain. There is difference of parent chain. In this, it has 4 carbon atoms. In this, it has 5 carbon atoms. So this means this is parent chain isomer. Or you can say simply, this is chain isomerism. This is chain isomerism. A very important question. A very important question. So this is a chain isomerism. This is not a position isomerism. Okay, everyone. This is a chain isomerism. The reason is there is difference in the parent chain, and always when you have carbon containing function groups, the position starts from that function group only. Okay, so this is a chain isomerism. This is not a function. This is not a position isomer. Okay, perfect. Perfect. Very nice. Very nice. Okay, understood everyone? Understood everyone? Yes. So now we have completed so many right now. But now next is metamerism. What is metamerism? Very simple, very simple. Okay. This is the same molecular formula and different alkyl chains on the both sides. And this particular isomerism is shown by bridging groups. This is shown by bridging groups. What do you mean by bridging groups? What do you mean by bridging groups? Like you have a river, right? And one city is here, one city is here. So what is built in between them? There is a bridge in between them. So these are bridging. These are bridges. So same way, we have one alkyl chain here, one alkyl chain here, and there is a bridging functional group in between that. Okay. So the examples of these bridging functional groups are these. So there is one alkyl chain here, one alkyl chain here, and this is the bridging functional group, that is ether. Right? Alkyl group, bridging function group. Alkyl group, and this is the bridge. Alkyl, and this is the bridge. So now there will be different alkyl chain on both sides, but the molecular formula will be same. So now let us see few examples of this. For example, you have this example, and this was the question of 2023. This was the question of 2023. You can see your paper. A question from metamerism has been asked in 2023 question paper. Okay, so I'm not making it up. This is actual. They ask these such questions which are very simple, very easy to solve, but you usually skip it because you are like, okay, nobody is going to ask these questions from isomerism. But actually, they have asked 2023 question from metamerism, and a very simple question. A very simple question. You get free 4 marks. Free 4 marks. Okay. So now let us see these two things. So there is one alkyl group here, one alkyl group here. This is a bridging functional group, right? One alkyl group here, one alkyl group here. As you can see, the alkyl chains are different here. The alkyl chains are different here. Here we have 2 ethyl, here we have 2 ethyl, and in the second structure, we have 1 methyl and 1 propyl. But the functional group in both these, but the molecular formula in both these structures are same. There is difference of alkyl groups. So this is the metamerism. Okay, this shows metamerism. Okay, Ji, this shows metamerism. Understood, everyone? This shows metamerism. As you can also see, I can also draw one more structure. That is also metamer. That is C, and this is CH3. This is H, and this is CH3. This is also a metamer of these two structures. Okay, this is also a metamer of these two structures that we have discussed here. This one is also, these three are metamers of each other because they have same functional group, but the alkyl chain in both the alkyl chains here and here are different. Okay, understood? So this is metamerism. Understood, everyone? So next is a very simple, that is functional isomerism. Functional isomerism, as the name says, there will be difference of functional group. There will be difference. The functional group will change. If there is alcohol, that will be changed to ether. Okay. So there will be change in functional group. If there is aldehyde and ketone are showing functional isomerism. So let us see few examples. This is the first example. As you can see, this is alcohol. The molecular formula is same in both the cases. This is alcohol. And just by shifting few atoms, just by breaking few linkages, we can convert this alcohol, not convert, but this is alcohol and this is ether. This is ether, right? So they both are actually functional. They both are showing functional isomerism. So if we see this one, this is a carboxylic acid. And if we convert, if we are changing the arrangement of atoms, now this becomes ester. In both these cases, the molecular formula is same. There's just the functional group has changed. Molecular formula remains same. The functional group has changed. Understood? Perfect. Okay. Now next is cyanide and isocyanide. This is linked to Cn and this is linked to nitrogen. This is linked to carbon. Here the alkyl chain is linked to nitrogen. These are also functional isomerism. Functional group have changed. Next is, this is ketone and this is aldehyde. Again, they have same molecular formula, but the functional group, the properties will be changed. The functional group will be changed, the properties will be different. But the number of atoms, the kind of atoms, everything is same here. Now next is very simple, ring chain. The easiest of all isomerism. One, you will be given a ring and this will be given an open chain. But the condition is, the ring will not be unsaturated. This will not have any double bond. But here you will find a double bond. Only in that case you can say that the formula is same. In this we have carbon 3 and we have hydrogen 6. Right? In this case also we have carbon 3 and we have hydrogen 6. So these two are showing ring chain isomerism. One is ring and the other is a chain. One is ring and the other is the chain. That is ring chain isomerism. Till now, have you understood everything? Everyone in the chat box, till now have you understood? So now we are going to do few questions. So I can proceed if you have understood till now. Okay? Perfect. So now let us proceed to the questions here. Let us proceed to the question. Few of them are PYQs, so let us see. Tell me about the first question. What is the relation? What kind of isomerism is this? In the first question, what kind of isomerism is this? Now you can see, firstly predict the longest chain here. Now we will see 1, 2, 3, 4, 5, 6, 7. And here you have 1, 2, 3, 4, 5, 6. Now you can easily predict. Now there is difference in the number of carbons in the parent chain. So parent chain is different. That means this is a chain isomer. This is a, I want everyone to answer this question. Everyone to answer this question, okay? Not only few students, everyone in the chat box answer these questions. So now you have these two. What is the relation between this and this? What is the relation between this and this? Okay, ma'am. Let us see what is the relation. Firstly, always predict the longest chain. Always. Firstly, do this. Always predict the longest chain. So now you have this carbon and this carbon. Okay. So now I am giving this number 1 and giving this number 2. Right. And here you have this carbon and this carbon. I am giving this number 1, number 2. Now what you will see? What you will see? You will see, ma'am, the position of OH, the parent chain is same. Right. The parent chain is same. But ma'am, the position of OH has changed. Here both the OH are on the first position, and here both the OH, one OH is on the first position, one OH is on the second position. That means this is a position isomer. That means this is a position isomer. Very nice students, very nice, very well done. Now let us see the third question. Let us see who will answer this question. Now this is, what is the relation between this particular and this particular structure? Firstly, always predict the longest chain. After that, see if there is any change in the position. If the parent chain is same, then see if there is any change in the functional group. Okay? Firstly, see the parent chain. Then if that is same, if that is same, if that is different, then it's a chain isomerism. Okay, if that is not same, then see the position of function group. If that is also same, then see the functional group. Okay, so these are the three things that you need to see. So first is the longest chain here. So that will be 1, 2, 3, 4. And here the longest chain will be 1, 2, 3, 4. But can't you see? This is a aldehyde, this is a ketonic group. There is a alkyl chain and in between there is a carbonyl group. And here the carbonyl group is on the terminal position. So that means this is the aldehyde. So that means what is this? What is this? There is change in the functional group. You can't say that, ma'am, this is the position isomer because here that is on the second position, this is on the first position, because here not only the position have changed, because of position the functional group have entirely changed. So that means this is a functional group isomerism. This is a functional group isomerism. Understood, everyone? Very good. Third is a functional group isomerism. Then coming to fourth, then we have these two. Let us predict the longest chain here. 1, 2, 3. Okay. And here 1, 2, 3, 4. Ma'am, this is, kya bologe? What you will say? What you will say? What you will say? Ma'am, this is parent chain. The parent chain is different. But can you see? Can you see? This is a surprise for you. Sometimes what they do is, this is not even isomerism. This is not even isomerism, Diksha. This is not even isomerism. The molecular formula here is not same. So they are not isomers, okay? They are not isomers. So this is a kind of fun game, right? Okay? I just wanted to check if you are able to see that these are not even isomers of each other. Right? These are not even isomers of each other. Then how can you say what kind of isomerism, ma'am? Right? Okay. So this is the last question of this particular thing. Now answer this question. Everyone in the chat box. Everyone in the chat box. So now you have two ethers here. Like two ethers. You can see this is the first alkyl chain and this is the second alkyl chain that is between this ether. And now these are the two alkyl chains. We can clearly see the molecular formula is same, but the alkyl chains are different in both these structures. Here we have methyl and propyl, and here we have ethyl and ethyl. That means these are metamers of each other. These are metamers of each other, and 2023 question has been asked from metamerism. Okay, and my prediction is that in 2024, question will be asked from tautomerism. A question will be asked from tautomerism, from structural isomerism. Okay, so we are going to start that only. A very important isomerism. You can see if you are in 12th, you already know the use of this tautomerism word. This has been included in so many reactions where you apply this tautomerism and then you get the desired product. And if you don't know what is tautomerism, then it becomes very difficult to answer the question when you are given the desired product. What is the desired product? You don't know if there is tautomerism involved, right? So for that, either this will be asked directly or this will be asked through some reaction. Okay, understood? So let us do what is tautomerism. A very simple, very interesting topic, yet a very important topic, right? A very important yet very simple topic. So let us do this. Tautomerism. What are the other names of tautomerism? Just for your information, nobody is going to ask you this, but just for your information, you don't need to cram this. Okay, you don't need to cram this. Just for your information, this is also called cryptotropism, allotropism, destotropism, prototropism. This is also named as this. Okay, there are very rare chances that they will ask such kind of question because the level has increased. So the question that will be asked, I'll tell you what kind of question will be asked. Firstly, let us understand what are the conditions of tautomerism. What are the conditions? So there are basically what happens in tautomerism. Firstly, let us understand that in tautomerism, H positive, why it is called prototropism? Because a proton, a H positive, is transferred intramolecularly. That means in a molecule only, one proton will be transferred from one place to another place in that molecule itself. Right? That is prototropism or tautomerism. Okay? So now this is alpha carbon should be sp3 hybridized. At least one alpha hydrogen. Ma'am, what are these two conditions? What do you mean by these two conditions? So firstly, let us understand what is alpha hydrogen. As you all know, if there is a group like this, this is the main group. The carbon attached adjacent to the main group is called alpha carbon. He is saying the alpha carbon should be sp3 hybridized. That means this alpha carbon should have sigma plus lone pair is equals to 4. Okay, that is how you say it is sp3 hybridized. And second condition is it should have at least one hydrogen. At least one hydrogen, because this hydrogen is only going to transfer. This H positive is alpha hydrogen. This H positive that is going to transfer intramolecularly is this alpha hydrogen only. So there should be at least one alpha carbon, that is sp3 hybridized, and that sp3 hybridized alpha carbon should have at least one alpha hydrogen, so as to transfer it intramolecularly to generate the tautomerism here. Okay, perfect. So now let us try to do this. I'm not going to tell you a very tough method to tautomerize these things. A very simple trick. Just simply write 1, 2, 3 and just replace it. Very simple trick. So let us understand this. A very simple trick. You will be given this kind of structure. Firstly, let us predict this is the main group, right? Ma'am, yes. This is the main group. Perfect. Now, what are the alpha carbon? Ma'am, this is the alpha carbon and this is the alpha carbon, right? This is the alpha carbon and this is the alpha carbon. So now you have in this alpha carbon, you have this 1, 2, 3 hydrogens. You have 1, 2, 3 hydrogens. That means there are so many hydrogens that can be transferred intramolecularly. But we will just focus on one hydrogen. Let us take the example of this particular hydrogen that is being transferred here. This hydrogen, I am taking the example of this hydrogen being transferred here. Just need to do 1, 2, 3 things. 1, 2, 3. Okay? 1, 2 ka 3, 1, 2 ka 3. That's it. This is 1, this is 2, this is 3. Okay? Now, draw the same structure but do not draw this hydrogen here. Do not draw this hydrogen here. Everything else, draw it the same way, right? You have drawn this, right? Now what you do here, what are the new things that you do here? Just this pi bond, the pi bond between 1, 2 will be shifted to 2, 3. The pi bond between 1, 2 will be shifted to 2, 3. And the hydrogen of third carbon will be shifted to 1. The pi bond between 1, 2 will be shifted to 2, 3, and hydrogen from third position to first position. That is the trick to solve these kind of questions. Just draw 1, 2, 3, shift the double bond from 1, 2 to 2, 3, and shift this third hydrogen, the hydrogen on alpha carbon, to the oxygen. That's it. Okay, and your tautomerism here is sorted. Okay, your tautomerism here is sorted. Understood, everyone? Okay, understood, everyone? Okay, bacha, understood, everyone? Have you understood this or not? Is this clear? Is this clear? Because this is a very important topic. This is a very important topic. If you tell me if you have understood this or not, so that we can, you know, do a lot of questions where these tautomerism are going to ask. Okay, perfect. Now let us do this. Just 1, 2 ka 3. You just need to do 1, 2, 3. 1, 2, 3. The double bond between 1, 2, switch it to 2, 3, and the hydrogen of third will be switched to 1. 1, 2, 3, and 1, 2, 3. Okay? Understood? So now here also we have already done this. Okay? So why this is called 1-3 system? Because bacha, the hydrogen from third carbon has been shifted to the first position. That is why it is called 1-3 system. Okay, that is why it is called 1-3 system. Understood? Now, let us find out how many of these will show, tautomerism. Let us understand. Okay, how many of these will show tautomerism? How many of these will show? So sweet, bacha, so sweet. Thank you so much. Thank you so much. But I just need this thing to make my day. Now I'm happy. Now I'm happy. You just need to, appreciate me, and I'm very happy, right? And this makes my day. This makes me more energetic. This makes me want to do more work for you, more hard work for you, right? So, okay, bacha, let us talk about the first structure here. Okay, so this is the main group here. This is the alpha and this is the alpha carbon. As you know, both the alpha carbon is sp3. So first condition is satisfied here. Let us jump to the second condition. The second condition is these alpha carbons should have hydrogen. So there are lots of hydrogens here. 1, 2, 3, 4. 4 hydrogens. We have 4 alpha hydrogens. So this will definitely show tautomerism. Right? So let us jump to this B part. Here we have this alpha and this alpha. This is sp2. This is sp2. So this will not show tautomerism. Right? This from this side it will not show tautomerism. This is sp3. So this carbon will show tautomerism. That means also this carbon have 2 hydrogens attached to it. So the condition here is also satisfied. Right? A and B will show tautomerism. Let us see C part. This is alpha, this is alpha. So now this alpha and this alpha. Both these alpha carbons are sp3 hybridized. First condition is here satisfied. But let us see about the second condition here. The second condition here is not satisfied. This carbon is sp3, but this does not have even a single alpha hydrogen. Even a single hydrogen is not attached to it. We need at least one alpha hydrogen which can be transferred intramolecularly. So that means this will not show tautomerism. And also D. What about D? Will this show tautomerism? This is alpha, this is alpha, this is sp2 and this is sp2. So that means this will also not show tautomerism. That means from this particular A and B will only show tautomerism. C and D will not show tautomerism. You can clearly see that. Okay? D is not and C is also not. Okay? D is not and C is also not. Now, let us see 1-5 system. Are you clear about 1-3 system? Now we will jump to 1-5 system. 1-5 system. That is, there is some kind of new thing that is added here, right? Something new is added here. Now, why it is called 1-3 system and what will be the conditions of 1-5 system? Okay, so now let us see. This is 1, this is 2, this is 3, this is 4, and this is 5. Is it? And this is 5. Is it? Right? This is 1, 2, 3, 4, and 5. Right? Okay, perfect. So now let us see what are the conditions. Mark my words. Mark my words. If the third carbon is sp2, what I am saying, you will apply this only when third carbon is sp2. Third carbon is sp2. Only then you will see if the fifth carbon is sp3 or sp2. Now here I saw that third carbon is sp2. That means 1-3 system cannot be applied here. 1-5 system is only applied when we have when we have third carbon that is sp2 and fifth carbon that is sp3 hybridized. Okay, 1-5 system is only applied when we have, I'm writing this here, only applied when third carbon is sp2 hybridized. Why I am saying this? If you have some example like this, where you have this, okay. Now you know this is sp3 hybridized, this is sp3 hybridized, and this is also sp3 hybridized. Okay, and counting this, we'll say 1, 2, 3, 4, 5. And now some of the students, what they do, they say from 1-3 position, from 1/3 position, it is not showing tautomerism. Let us apply 1-5 system here. You cannot apply that. Why? Because for 1-5 system, the third carbon should be sp2 hybridized. In this case, 1-5 system will not be applied. Not 1-3, not 1-5. No tautomerism will occur here, even from 1-5 system. Okay? Okay, bacha? Okay. Okay. Done? Understood this? Now, let us see what is happening here. Okay. This board sometimes surprises me as well, right? So, let us see how we are going to tautomerize this thing. Now, it has 2 hydrogens here, right? 2 hydrogens here. So, now what will happen? The switches between 1 and 5. What will happen here? The hydrogen from 5th position, this H positive will transfer intramolecularly to this position. And what will happen here? This bond, this sigma bond between carbon and hydrogen will be shifted to this one, this position between 4 and 5. And this double bond will be shifted to 2 and 3 position. And the double bond between 1 and 2 will be shifted to oxygen. And it will become O negative. And that is why this hydrogen will shift here. And it will be OH. And here it will be a double bond here, a double bond here, and a double bond here. And this will lead to phenol. Understood, everyone? This is 1-5 system. Right? What I have done here, I'll again repeat this thing one more time. Okay. So, bacha, what I have done, 1, 2, 3, 4, 5. As the third carbon here is sp2 hybridized, so I saw if the fifth carbon is also sp2 hybridized, but the fifth carbon is not sp2 hybridized. It is sp3. That means 1-5 system will occur here. 1-5 system will take place. 1-5 tautomerism will take place. So now for 1-5 tautomerism, what you do, just replace this hydrogen will jump to first position, from 5th position to first position, right? I have intramolecularly transferred this 5th hydrogen from 5th position to first position, and this bond between carbon and hydrogen has shifted to 4 and 5, and the 3 and 4 bond has been shifted to this one, 2 and 3, and the bond between the pi electrons between 1 and 2 has been shifted to oxygen itself, and oxygen becomes O negative, and that is why this hydrogen is intramolecularly shifted to this one, right? And that is the 1-5 system. Okay, Okay, everyone, this is called the 1-5 system. Everyone in the chat box? Okay, so I'll just write one chart on this. I'll draw one chart on this. How you will identify will this be tautomerized or not. Very simple chart. You just need to remember this chart and you're sorted for tautomerism. Okay, so firstly, what do you identify? Firstly, identify if there is alpha carbon. If there is alpha carbon. Firstly, what identify what? Firstly, identify if there is alpha carbon. If the alpha carbon is sp2 hybridized, if the alpha carbon is sp2 hybridized or the alpha carbon is sp3 hybridized. If the alpha carbon is sp3 hybridized, then what will happen? Check if there are alpha hydrogens. If there are no alpha hydrogen. If there are no alpha hydrogen, even though it is sp3 hybridized, then there will be no tautomerism. And if it is sp3 hybridized and there are alpha, at least one alpha hydrogen, that will show tautomerism, right? This was about if alpha carbon is sp3 hybridized. Understood? Now let us understand if alpha carbon is sp2 hybridized. What will happen when the alpha carbon is sp2 hybridized? What you will check? You will check these two things. If the alpha carbon is sp2 hybridized, just check the fifth carbon is sp3 or fifth carbon is sp2. Now, if the fifth carbon is also sp2, then there will be no tautomerism. But if the fifth carbon is sp3, now there will be tautomerism, and only in case if it also has alpha H, then there will be tautomerism. Everyone understood from this chart point of view? You just need to see alpha carbon. If alpha carbon is sp2, then you will see fifth carbon. If that is also sp3, then you will see alpha hydrogen, and that will be yes. If you have sp3, then alpha hydrogen, then also it is yes. Okay, everyone? Everyone in the chat box, have you understood this particular concept? This summarizes everything for tautomerism. Okay? Let us see some practice questions. Let us see some practice questions from your PYQs and so many reference books. Okay, some of my own, some of the structures that I have drawn myself. Okay, let us see. Let us see the tautomerism of these. Right? Will the first question show tautomerism or not? You just need to tell me yes or no. Yes or no. Tautomerism, yes or no. Tautomerism, yes or no. First is, I want you to answer this. I want you to answer this. Everyone in the chat box, I want you guys to answer this question. Will the first structure show isomerism? Will the second structure show isomerism? A very simple question. A very simple question. And these kind of questions are being asked in NEET examination. Okay? Okay. Perfect. Very good. First, no. Very nice. Because this is alpha, this is alpha, this is sp2, sp2. This is 1, 2, 3, 4, 5. Fifth is also sp2. So this will not show 1, 3, 1, 5 system. Nothing will show. Okay. Similarly, in this case, 1, 2, 3, 4, 5. Both third and fifth are sp2 hybridized. So no tautomerism in this case. Now let us see this case. What about the second case? What about the very good Rupa? Very nice. Very nice. Others. What about the second? What about the second? Now let us see 1, 2, 3, 4, 5. Even if I am taking 4, 5 here side, if I am taking 4, 5 this side, in both the cases, third and fifth are sp2 hybridized. So in this case, it will not show any tautomerism. But if I take 1, 2, 3, 4, and 5. Now here, third is sp2, but fifth is sp3 with alpha hydrogen. That means this will show tautomerism. As I told you, if you have third sp2, then fifth is sp3 with alpha hydrogen, that it shows tautomerism, right? So this will show tautomerism. The answer is yes. This is no and this is yes, right? Okay, perfect, everyone. Perfect. So now let us do some isomerism. Okay, so the isomerism that can be asked is a very, high level. This is a very high level, but very simple level. High level get very simple because we are already doing isomerism. The same concept will be applied here as well. There is no change in the concept. No change in the concept. So I don't want to take any risk because they have changed the syllabus, right? They have changed the syllabus. The syllabus is now shortened, right? They have deleted so many topics. That means the topics that are in the syllabus, that becomes already very important for you, right? Okay, so now this is one. Just from oxygen, type 1 2 3. Draw 1 2 3. That's it. 1 2 and 3. After that, what you do, this is carbon, this is CH3, this is alpha carbon, right? So this is H. Do not draw, always do not draw the alpha hydrogen of alpha carbon, right? So this is nitrogen, this is oxygen, and this is also oxygen. So what you need to do is replace the pi. But the bond between the double bond between 1 and 2 will be shifted to 2 and 3, will be shifted to 2 and 3, and the hydrogen of third carbon will be shifted to 1. This is the tautomerism. Very nice, very simple. That is nitro, Se nitro. This is nitro and this is Se nitro. Se nitro. Okay? Nitro, Se nitro. Understood? One more. There are so many examples. But there are so many examples. There are already another examples. Okay? So many examples. Let us see these examples. Okay? Let us see these examples. Okay. What you do? Oxygen 1, 2 and 3. 1, 2, 3. Then what you do? This is as it is. This is hydrogen. This is nitrogen and this is oxygen. The double bond between 1 and 2 will be shifted to 2 and 3. 1 and 2 will be shifted to 2 and 3. Right? And the hydrogen of third will be shifted to first. That means this. Okay? And this is oxide. Okay? This is oxide. Okay? This is oxide and this is nitroso. This is nitroso. Nitroso. Understood? Understood everyone? Just write 1, 2, 3. Shift the double bond of 1 and 2 to 2 and 3 and shift the hydrogen from third to first. Okay? I'm writing it here. I'm writing it here. I'm writing it here as well. Shift double bond of 1 and 2 to 2 and 3. Okay? Shift double bond of 1 and 2. I'm writing it here. Everyone write it down in your notes. Shift double bond. Shift double bond. This is the trick, okay? Double bond of 1 and 2 to 2 and 3. And then next is shift, yeah, transfer hydrogen on third position to first position. That's it. This solves your tautomerism. This thing will solve your tautomerism. If you are doing 1 5 shift, similarly from 1 to write 2 5. Okay, that's it. Replace 3 by 5. That's it. Okay, perfect. Last question means this one. This one. Are you talking about this one? This one? Okay, bacha, what are you talking about? Are you talking about this particular isomerism? This is 1, 2, 3. Okay, just shift the double bond of 1 and 2 to 2 and 3. I have shifted 1. This is 1. This is 2. This is 3. I have shifted the double bond of 1 and 2 to 2 and 3. And I have shifted the hydrogen of third to first. That's it. Okay. Similarly, I have done here. That's it. Same question. Same thing I have done everywhere. Same thing I am doing everywhere. Double bond shifting of 1 and 2 to 2 and 3. Double bond has been shifted to 1 and 2 to 2 and 3. That's it. And the hydrogen from third position to first position. Okay. Hydrogen from third position to first position. And here also, have you understood, bacha? Tell me. Now here also 1 and 2 to 2 and 3. See, this is 1, this is 2, this is 3. Okay. 1 and 2 to 2 and 3. And the hydrogen from third position to first position. That's it. Okay. That's it. Okay. Cycle question. Are you talking about this one? Are you talking about what I have told you? See, I told you that in this case you have third carbon, that is sp2 hybridized. If the third carbon is sp2 hybridized, what you see is, if the third carbon is sp2 hybridized, then you see if the fifth carbon is sp3 or sp2. Now we see here in this question the fifth carbon is sp3 hybridized. It is not sp2. So that means if the fifth carbon is sp3 hybridized, then we see, is there any alpha hydrogen? There are also two alpha hydrogen here. That means it will show tautomerism. Okay, this is the condition. This is the condition. Okay, understood? Understood? Okay. I don't know which question are you asking. Please elaborate, Diksha. Please elaborate. Okay, this is 1, 2, 3. Now shift the same thing here, do the same thing here, do the same thing here. Now you have this NH and this is first, this is 2, this is 3. Okay, in this, shift the double bond of 1 and 2 to 2 and 3. Shift the double bond from 1 and 2 to 2 and 3 and shift the hydrogen from third to first position. That is this. Okay, now it becomes enemy. Okay, right? This is mean and enemy. Understood? Okay, ma'am. Perfect. Perfect. Now, I'm happy that you have understood that. Is there any question regarding tautomerism? Anyone here? Sneha, Sahehna. I'm sorry if I'm pronouncing your name incorrectly. So is there any question regarding tautomerism till now? Any question? Any question till now? Any question? So we have completed structural isomerism. We have completed tautomerism. In tautomerism, just do two things. Okay, there are 1-3 system, I am saying 1-3 system and 1-5 system, right? So 1-3 system and 1-5 system. Just remember this chart always. Just remember these two things. This chart, and second is always remember this thing. Always remember this thing. That's it. These two things, just remember these two things and you will be able to solve all the questions based on tautomerism. Okay? Diamond clear? Perfect. Okay, perfect. Perfect. Thank you, yeah. Thank you. Thank you. Thank you so much. You just appreciate me in between so that my energy is, again high. Perfect. So now, bacha, we have completed structural isomerism. Okay, we have completed that. So guys, can you please tell me one more thing? I just want to chit chat a bit. Is there any issue in the voice? Everyone in the chat box, can you identify any issue? Because when I see my video, I feel there is some echo in the voice, right? I feel that. Do you also feel the same? So that I can, eradicate that factor. So that I can work on that thing. So what is the problem? I can talk to the team and see if there is any problem regarding voice and audio, any echo issues. Any issues? No, ma'am. No, ma'am. Okay, perfect. Okay then. Okay. Actually, yesterday I was actually listening to my video and I thought there is some echo issues. So, okay, fine. I'll take your words. So now let us start structural isomerism. We have completed. We are going to start stereoisomerism. As I told you, stereoisomerism is us. What we are, what we do. We have this body. If my head is paining, I can't just take out my head and place it somewhere. I can just take out my arms and place it somewhere. Oh, my arms are paining. I can't do that, right? So this stereoisomerism is the same way. The linkage is same. There's the difference, and there is no difference in the linkage. The linkage is same. Only I can rotate my arm. I can rotate my head. That means that thing I can do. So that means I can rotate my these are atoms only. I can rotate my arms and head in the space. Space means stereo. Okay, stereo means space. Okay, stereo means space. So stereo means us. We cannot change the linkage. We can change the spatial arrangement, how we are rotating our arms in the space. Similarly, that is for the atoms. Okay, perfect. So now let us see. There are two kind of isomerism here. First is configurational isomerism. Second is conformational isomerism. And conformations have been specially mentioned in your syllabus. As you can see, these are specially mentioned in your syllabus. These are also mentioned, and this has been specially mentioned in hydrocarbons. This is specially mentioned in hydrocarbons. Hydrocarbons, they have written conformers of ethane. Okay, so they will ask those conformer, and we will do this particular topic in hydrocarbons. We will cover this topic in hydrocarbons only, and today we are going to complete this topic. A very tricky topic that students usually find very difficult. That is geometrical and optical. I'll make it very simple for you. Very simple, very easy for you. My students who have been teaching, who have been studying from me from a long time, they know that how I teach these two topics. I make this very easy. I trust me on that. Okay, trust me on that. Okay, so let us start. First is geometrical isomerism. Second is stereoisomerism. Second is optical isomerism. Optical isomerism has also been included in haloalkene, L and arene. Okay, haloalkanes and arenes. Okay, this topics has been also included in haloalkanes and haloarenes, and also in bimolecules. Right? Okay. Yes. Clarity. Okay. Just wait a minute. Let me see if I can focus it. Is this now clear? Is this now better? Let me see if it is now better. Just wait a minute. Let me see. I have done some kind of jugaad here. Okay. Yeah, let's see that. Okay, so I think that is better now, is it? Okay, so now that is geometrical isomerism. Geometrical isomerism will do cis-trans isomerism. You all know cis-trans isomerism, very famous. EZ isomerism and then anti-syn isomerism. These are the three topics that we are going to cover in geometrical isomerism. Okay, so now firstly let us see what all shows geometrical isomerism. The geometrical isomerism is shown by when there is restricted rotation. Okay, when there is restricted rotation. Okay, there are some of the poses that you cannot do, that your body cannot do. Okay, you can't just rotate your head backwards, right? Oh my god, that will be a ghosty thing. And if you can only rotate your head like this. Okay, like this. You can't rotate your head like totally backwards. Like, so that is a ghosty thing. That means there is restricted rotation till that part. So similarly, in case of compounds, there is restricted rotation as well. The restricted rotation is in case of double bonds, and in case of rings. So we are going to discuss these two, double bonds and rings. Okay, we are going to discuss restricted rotation and double bonds and rings, right? So what is they have written another condition. First, there should be double bond or rings. Second condition is different group on same side of double bond. Oh, kya baat hai? Very nice. Different group on the same side. That means you have this double bond. This is 1, this is 2, this is 3, and this is 4. So they are saying 3 should never be equals to 4 and 1 should never be equals to 2. This should never be equals to this. This should never be equals to this. 3 should never be equals to 4 and 1 should never be equals to 2. That is what they are saying, that there should be different groups on the same side of double bonds. This is the same side. This is the same side. Okay? Understood, everyone? Now let us see few things. Let us see few questions where you can easily identify what do we mean by this particular condition. Okay? So for A part, this is A part, this is B part. For A part, you can say double bond is here, so restricted rotation is here, right? So let us see the next condition. That is, this particular group can never be same with this group, and this group can never be same with this group. As these two groups are same, that means this is not following geometrical isomerism. Okay, that means they are not geometrical isomerism of each other. There is no GI, no cis trans, no EZ, nothing, no cis anti. Okay, no geometrical isomerism here. No geometrical isomerism here. Next is these two groups are also same. What does that mean? What does that mean? Then this will also not show geometrical isomerism. Okay, this will also not show geometrical isomerism. Everyone understood? This is the first side, this is the second side. That means they are saying, I can also write it this different on the same side or on the same carbon. Same carbon. Both the group on the same carbon should be different. On the same carbon, the groups should be different. Here the same one carbon, the group should be different, but the groups are same, so no GI. Okay, the groups are same on the same carbon, that is not GI, right? Okay, so now let us understand this. Let us understand some, with the help of some tricky questions. I'm not just going to define this and just go away, right? I'm not going to do that. I will take the best examples, best tricky examples as well to solve these questions, so that no one, even if the paper is very tough, you will crack that paper. Okay, you will definitely crack that paper even if the paper is very difficult. I am preparing for you for that thing, right? Okay, so now let us understand this. Now, see, this is the double bond, perfect. There is restricted rotation, right? Second is, these two groups are different, perfect. One condition is satisfied. Now, what about these two groups, ma'am? How do we take these groups? How can we say if this is same or not? This is the same ring, ma'am. How can we say? How can we identify if the groups are same or not? In this case, see the environment. Like, walk from this face and walk from this case. In this case, you meet CH2. In this case also, you meet CH2. That means same environment. In this case, you meet CH2. In this case also, you meet CH2. That means same environment. So if the environment is same, that means the groups are same. No. Cis trans, we are only going to understand cis and trans once we are able to understand if they show geometrical isomerism or not. If they are not going to show geometrical isomerism, then no cis and trans, no E and Z, nothing. Okay, they are not GIs. They do not show geometrical isomerism only. Right? So geometrical isomerism, but firstly we will see if they show geometrical isomerism or no. After that, we will find out if they're cis or trans, they're E or Z, what kind of geometrical isomerism is that. Okay, what? Yes, please ask the doubt. Yes. Oh my God. Thank you, yeah. Thank you so much. Thank you. So understand that. So there is first, here we will see CH2, here also you will see CH2. Here also you will see CH2. That means you are going in two directions and you are facing the same kind of conditions. So that means the environment is same, and when you have this kind of question, you will see the environment. If the environment is same, that means the groups are same. That means it will not show geometrical isomerism. No geometrical isomerism here. Okay? No geometrical isomerism in this case. Understood? Now we will see this B part. Now if you can see this, in the same carbon, you have two different groups. That means we are sorted. In this case, we have different groups. We are sorted with this. Now let us talk about this particular carbon. Do we have different environment here or we have same environment here? Go step by step. Always remember, in these kind of question, go step by step. Okay, what kind of step? Let us see. Now, in this step, you meet bromine, and here you will meet chlorine. That means in one part you meet bromine, and the second part you meet chlorine. Bromine and chlorine are different, no? They are different. That means the environment is different. So that means these two things are not same. And if on the same carbon, the groups are different, the environment is different, that means they show geometrical isomerism. So here they show geometrical isomerism. Okay? Here they show geometrical isomerism. No issues, bacha, no issues. Very welcome to the class. Understood, bacha? So here, the groups, the environment are different. Every step you will see in these kind of question, in every step you see if the environment is same or different. In this step you meet bromine and in this step you meet chlorine. That means the environment is different here. So here you will see that this shows geometrical isomerism. Okay, this means this shows geometrical isomerism. Understood, everyone? Understood? Perfect. So now let us see the next question. This is A and this is B. Same way we are going to apply this thing. Here also you have double bond. Perfect. Here also you have methyl and methyl. You don't need to go here. You don't need to see this. Here only you can see the methyl and methyl group. That means on same carbon, on the same side, you find out that there is one group that is placed on both the things, right? So in this at this carbon, both the methyl groups are same. Both the groups are same. So that means it will not show geometrical isomerism. This will not show geometrical isomerism. Perfect. This in 3 and 4, the environment different or ma'am, in chlorine and bromine, in 3 and 4, carbon, the environment are different. Yes. Don't name this 3 and 4. Just walk here and walk here. Okay. Here you met bromine and here you met chlorine. Okay. That means the environment is different. We'll see more questions on that. So that will be very easy for you to understand. Okay. More examples. So many examples I have for you. Right. I just need your time. Okay. So this is double bond. This is double bond. Right. At this carbon, these two groups are different. That means condition is satisfied here. What about this carbon? What about this carbon? When you go walk this side and walk this side. On this side you met this CH2 and CH2. CH2 and CH2. Same. They are same. Now let us walk another. Now on this side you met bromine. And in this side there is no bromine. Here you met bromine. There is no bromine. That means the environment here has changed. The environment here has changed. What does that mean? That means that the environment has changed. The groups are different. This will show geometrical isomerism. This will show geometrical isomerism, right? So the environment becomes different. Bromine and there is no bromine. The environment becomes different. So that means this will show geometrical isomerism. Okay? Perfect. Understood, everyone? Everyone, are you able to understand this thing? Any doubts till now? Any doubts? Bachcho, any doubts till now? Tell me, any doubts till now? Okay. Any doubts till now? You don't need to feel demotivated, bacha. Don't feel demotivated. Just work hard. Work hard. If you're working hard, if you're giving your 100%, then you will definitely achieve your goal. You will definitely, if you're just, now I understand there are days when we feel demotivated, but in that day, always remember, you are feeling here demotivated, but someone else is working hard. Someone else is giving up on their sleep and everything, on their parties, everything, just for this little dream, just for this big dream. I won't say little dream, for this big dream, right? So whenever you are feeling demotivated, just remember and manifest you as a doctor and you are treating your patients, right? And everyone is praising you. Now, what a doctor he is. He's an amazing doctor. She's an amazing doctor. So caring, so loving, right? Always remember that thing and go and study. Go and study. That should be unstoppable. Nobody on this planet should stop you from studying. Nothing, okay? Always remember this, okay? So this is A and this is B. This is A and this is B. Now this is double bond. Let us see on these two atoms. These two atoms are different, right? And what about this environment? Very important. Very, very important question. Very important question. Okay? Bacha, that is what we are doing now. Geometrical isomerism is that is what you are doing now. If this shows geometrical isomerism or not. Okay? So, in geometrical isomerism, firstly find out if they have double bond, right? If they have double bond, the carbon atom Okay, this carbon atom should have different groups and this carbon atom should also have different groups. If there are different groups on both the sides, then we say that it shows geometrical isomerism. Okay, so now here we have different groups and here also you met CH2 and CH2. That means the same environment. And here so many of you say, ma'am, this particular person will meet bromine and this way we will meet chlorine. But bacha, here it is like this, it is like this, it is like this, okay? If you're going to one particular destination, if here me and Gopika ma'am is chatting, this is me and this is Gopika ma'am, okay? We are in our office and we are chatting. Now, if you came to meet us, if you come to meet Gopika ma'am or me, you will definitely see both of us, no? You will see both of us. So here also, they saw both of us, they saw chlorine and bromine also. They are at the same point. They are at the same point. That means that at the same point means the environment is same. The Gopika ma'am and me are standing on the same point in the same room. So if you say, if you come, you will greet both of us, right? You will greet both of us. So that is why here also it will greet chlorine also and bromine also. So that means the environment here is same, as chlorine and bromine are on the same position. So here it will show geometrical isomerism. Understood? Okay, bacha. Okay, bacha. Bacha, tell me. Yes, we will. Bacha, I will definitely. Don't worry. Don't worry. Just I would just advise you to just 3 months are left. Don't worry. Don't panic out. I understand these things happen. Sometimes you do feel motivated. You self-doubt yourself. But trust me, this happens to everyone. Even the topper doubts themselves, right? This is a very normal human feeling that we feel whenever we are going to do something big. That means your dreams are big, right? Your dreams are that big that they makes you doubt yourself. Okay, if you have a dream of becoming a normal something, a dream of becoming anything that everybody can do, going into a normal college, right, doing a simple course that everyone can do, they won't doubt themselves because that is very easy, because your dream is tough to achieve. That is why you sometimes feel demotivated, you sometimes feel, okay, I don't know if I can do this or not. But if your goal is, pinpoint, okay, I have to do this and I'll do anything to achieve that goal, anything to achieve that goal, in that way you will achieve that goal. Just manifest that and work hard on that. This is a very normal feeling. Everyone gets this feeling. Even I feel sometimes, okay? It's a very normal feeling. You are human, that why you are feeling this way. Okay, this is no different that you are feeling. So I know sometimes we do feel that way, but just focus on that. And, counter your fears like that. Yeah. Everyone do this. Everyone do this, okay? So now, I don't understand this. Okay. I'll repeat this again. This is the tricky question, so I'll repeat this again. I know this is the tricky question. Okay, so now this thing is making you confused, right? This is a very important question, very interesting question. Let us see. In this point, you met CH2 and here also you met CH2. That means the environment is same. Now let us jump again. Here you met C, okay? And this C is attached to one bromine and one chlorine. Now, if this is carbon and this is attached to one chlorine and one bromine. So now, if someone is looking at this carbon, they will see both bromine and both chlorine on this carbon. That means the environment is same here. The position is same here. For example, me and Gopika ma'am are sitting in one room. And if you're coming in that room, you can't ignore one person and see the other person, right? You have to greet both the persons. And if you're coming in a room, if you're entering a room and there are two people sitting, you can just ignore chlorine and greet bromine. You can greet bromine and ignore chlorine. Okay? So both the chlorine and bromine are sitting at one point. That means the environment is same. Okay, if you're looking this way or that way, the environment will be same. There is chlorine and there is bromine on that particular position. That means the environment have not changed. The environment is still the same. Okay, perfect. Understood? That is why I say, okay. Sorry, I have written yes here. Why I have written yes here? The environment is same. The environment is same. So there will be no GI. No GI will be here. Right? The environment is Same here. So that is why no geometrical isomerism will be here. Understood, everyone? Understood? Shishadri, understood this or not? Bacha, tell me. Okay. Yes. Chemistry teaches basic manners as well. Okay. You have to greet bromine and chlorine as well. Because they are both sitting in the same room. You can't just ignore one and just greet hello, how are you to other person, right? This is basic manners, no? Right? Okay? Okay. Bacha, see, you have to see one environment, right? You have to see one environment. In one environment, I'm talking about the environment here. This bromine and chlorine are sitting at the same position. If the position is same, if you see through this side or you see through this side, chlorine and bromine are on the same position only. And that is why the environment is not different. We have to see the environment. The environment will be different if chlorine is here and bromine is here. They are sitting on the different position. Here also by 2 steps you have come to chlorine and bromine. Here also by 2 steps you have come to chlorine and bromine. So the steps are same. Okay? Then that is why. Okay, perfect. Now fine. I don't let any student in my class go with any doubt. Okay? Any doubt. I don't want you to doubt yourself or any doubt in the class as well. Right? Okay. I'll make sure that. Don't worry. So, beta, now in B part, you have these 2 carbon atoms. This is chlorine and this is bromine. Right? These 2 are different. Very simple. We know that one. It is clearly visible. Right? Now, let us talk about this side. This was the most difficult question. I'm telling you, this was the most difficult question. Most tricky question this was. Okay? So, now in this case, you have CH2 and you have CH2. That means you are meeting the same persons. These are twins. Same. Right? And in this case, you met methyl, but here you met no methyl. Here there was no methyl. That means when you are taking 2 steps from this side, 2 steps from this side, you met methyl, and 2 steps from this side, no methyl is here. That means the environment is different. So if the environment is different on both the carbons, that means it will show geometrical isomerism. It will show geometrical isomerism here. Okay, understand everyone? Understood? Understood everyone? Tell me in the chat box, understood or not? Everyone in the chat box, understood or not? Very nice, very nice. So let us understand this thing. You have this double bond here, right? What? Just one thing in your mind. Each carbon of that double bond, this is one carbon, this is another double bond between them, right? One carbon, one carbon. This carbon should have different environment or different groups. This carbon should also have different groups. Okay? That's it. Now let us see. This is the first carbon, this is second carbon. Here, I am moving here and here. In this side, I met CH2. And at this side, I met a carbon that is sp2 hybridized. At this side, I met a carbon that is sp3 hybridized. That means the environment here is different. That means the environment here is different. Okay, so here the environment is different, and here also I met a carbon which has double bond, and here I met a carbon that has single bond. That means the environment is different here as well, so it will show geometrical isomerism. And in this case, this is carbon and this is carbon. Now ma'am, what to do? Now see, here I met CH2, here also I met CH2, right? Here also they both met CH2. Now they are both at the same point, meeting the same environment, right? That means the environment is same. Here also CH2, CH2. And finally they are at the same point where the environment is same. At same point, that means the environment is same, right? So here also the environment is same, so this will not show geometrical isomerism. Okay, this will not show geometrical isomerism. Sure, before April, sure, the syllabus is going to get complete. So many things are coming up for you. Don't worry. So many new things are coming up for you. Don't worry. Okay, okay, just trust us and just keep going, right? Before April, before that only. Okay. Okay, let us see. Now next is, this Now we have completed cis or trans. We have completed will this show geometrical isomerism or no? And these were the only question that has been asked, right? Most trickiest question I have taken already, right? So now let us understood cis and trans. Cis means sisters. What is all sisters? Sisters are always there for you, right? Sisters are always sitting next to each other. So the sisters are always sitting next to each other. Sister will always be sitting next to each other. And this is between two different carbon atoms. Okay? So there are two carbon atoms between this double bond, and this sisters will be, this is cis because sisters are always sitting next to each other, and those who are not sisters, they are sitting opposite to each other, and that is why this is trans. A very simple thing, sisters are always sitting next to each other, gossiping about this and that, right? That's what sisters do, right? Okay. Alright, that will be finished. Don't worry. So many one shots are coming in your way, but just coming for you. But just one thing I need for you. Just one promise I need from you. That is, whenever the class is happening, you have to attend the class, and there will be a class of 3 to 4 hours. If you want to complete organic in detail manner, with NEET point of view, at the level of question will be very good, so that if the paper is very difficult, even then you will be able to solve that. If you want that in detail and one shot, you have to be here for at least 4 hours. Like I'll complete that in 3 to 4 hours, but you have to be here. Okay, if you can do that, I'll complete the syllabus. Okay, I'll complete I'll complete the syllabus, but I'll complete the syllabus unexpectedly in few days. Okay, in few, just 1 hour, one chapter 1 day, but in detail we will cover. Okay, yes, if you're giving me that promise, that's my promise to you. Okay, perfect. So now next is, this is A, this is B. Okay, this is A, this is B. Now let us see. Chlorine is sitting next to each other. These two are not same. Chlorines are sitting next to each other. So this is cis. Okay. Sisters are those who sit next to each other and gossip about everything in this universe, right? So these are sisters. So that is cis. Now this is actually opposite to each other. Opposite to each other. So that means this is trans. That means this is trans. Okay. That means this is trans. Okay. Perfect. Perfect. Understood? We have completed geometrical isomerism, conditions for geometrical isomerism, and now we are going to do E and Z. Till now, any confusion, any question of any student here? Any confusion, any question here? Any question, anything, any question? Okay. Done? Perfect. 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 So now let us discuss E and Z. Very simple. Z means same side, E means opposite side. Z means same side, E means opposite side. Now, for example, you have this double bond, and all these four groups are different. Now, how can you decide which is sitting next to each other? Now, for example, I'm giving you an example. These are the examples. I'm giving you this example. In this case, you have 1, 2, 3, 4. All the four groups here are different. So how can you decide? This is geometrical isomerism. But on the same carbon, you have different groups. But you cannot decide if this is cis or trans. In that case, you give priority. And that is by CIP rule. Okay, that is by CIP rule. That is Carl in gold prelogue. These are the name of scientists. And what does this rule say? Let us see what does this rule say. This rule say that priority order will be according to the atomic number. More is the atomic number, more is the priority. The priority number 1 will be given to out of these which will have maximum atomic number. That will be given first priority. And if we are talking about isotopes which have same atomic number, then which of these two will have more molecular mass will be given first priority. Okay, the priority will be according to atomic number, and in case of isotopes, according to molecular weight or molecular mass. That is CIP rule. And CIP rule will also be included in RS configuration. When we will discuss RS configuration, in that case also CIP rule will also be included in that case. Okay, perfect. Now let us see this. Let us see this. Let us see. Okay, okay. Let us see this. Perfect. Very nice. Now you have this. Prioritize 1 and 2 on both these sides. Firstly, this side on carbon number 1, this is carbon number 2. On carbon number 1, you have chlorine and this C. And here also, always remember one thing. Listen, listen, listen. Here, listen. Always go step by step. That means you will focus on the first atom. You will focus on the first person you meet. Right? You will focus on the first person you meet. That's it. Okay? Here you met chlorine. Here you met carbon. Do not include other atoms here. Do not include other atoms here. Just always focus on the first person that you met. Okay? So this is chlorine and this is carbon. So halogen has more atomic number as compared to carbon. So the priority is 1 and this is 2. Okay? This is 1 and this is 2. Step by step. Step by step, one by one. First person you met is the priority order. Right? So here you met nitrogen and here you met hydrogen. Hydrogen is least, it has atomic number, very less atomic number, it's just 1 atomic number. Priority is 2. Nitrogen is always number 1 if it is compared to hydrogen, right? So the priority is 1, 1 and 2, 2. Now see this thing. Now you can see 1, 1, 2, 2. You can see that is actually straight line. If you can see straight line, the answer will be opposite. The answer will be Z. Okay? The answer will be Z. You can also see it like this. 1, 1, 2, 2. That means on the same side. On the same side. This is same side. This is same side. Right? These are on the same side. And for same side you have Z. For same side you have Z. So write it as Z. The configuration here is Z. Okay? Understood? The configuration here is Z. Let us do some few more examples so that you are able to understand it more. Right? Okay? So this is the double bond. Firstly, let us see this carbon number 1 and this carbon number 2. For carbon number 1, you have hydrogen and you have chlorine. For carbon number 1, you have hydrogen and you have chlorine. Right? Hydrogen, least priority. Out of this is the number 1. This is number 2, atomic number more. And out of this, you met carbon here. Here you met CH carbon here. Now, these are twins. You have met carbon only. Here also you met carbon. Here also you met carbon. What to do, ma'am? What to do now? See. Hey, in this case, what you do is this. In this case, always do this. This is C, this is H, this is H, this is H. Okay? Understand this very carefully. Understand this very carefully. Here you met this carbon, here you met this carbon. This carbon has 2 hydrogens and this carbon also has 2 hydrogens. But this carbon is not, at this point, everything is same. At this point, there is no differentiating factor. The differentiating factor is that this carbon is attached to 1 hydrogen more and this carbon is further attached to 1 carbon. That means the priority of this carbon, this particular group will be more as compared to this. Every step you have to see the atomic number. Every step. Now this carbon is 2 hydrogen, this carbon 2 hydrogen. But this carbon is further attached to 1 more carbon. This carbon is further attached to 1 hydrogen. So the difference here, differentiating factor here is this hydrogen and this carbon. Right? So this is the number 1 priority. This is the second priority. So I'll say 1 and I'll say 2. Understood? Understood? And this is 1, 1, 2, 2. That means same side. That means it is Z. 1, 1, 2, 2. Same side. That means it is Z. Okay? Okay. Perfect. Now. No. Very nice question. Very nice question. Very nice. Okay, but never see molecular mass. Never see molecular mass unless and until they are isotopes. Always go step by step and see the atoms. And you just need to see one atom, just one atom. You just need to see one differentiating factor. Okay, always see the differentiating factor. Never see the molecular mass. Never. That will give you a wrong answer. In some cases, you will get the right answer. In some cases, you will get the wrong answer. So the perfect thing is always see the differentiating factor. Here, everything is same except for this carbon and this hydrogen. So the moment you see one different thing, and that moment stop there and give the priority order. The moment you see a differentiating factor, stop there and give it priority order. Okay? Right? Now let us see this. Let us see this. Let us see this. This question. These are the isotopes, right? This is hydrogen. This is tritium. As I told you, in case of isotopes, less molecular mass will be least priority. So this is number 1 and this is number 2. And in this case, let us see. In this case also, this is same. This is same. This is the differentiating factor. Here we have oxygen 18 and here we have oxygen 16. That means oxygen 18 has more molecular mass and this has less. So this is 2, 1 and this is 1. That means you have opposite. These are opposite to each other. So the answer will be E. The answer here will be E. Right? The answer here will be E. Understood everyone? Here the differentiating factor is isotopes. They are isotopes of each other. And for isotopes you see molecular mass. You see molecular mass. More the molecular mass, more will be the priority. That means the highest molecular mass will get number 1 priority. Right? Okay? Perfect. Now let us see. I have taken all the tricky questions, but though this was a session where I have to compile everything in this session, but even then I have taken all the tricky question in this session. The reason being, I don't want you to miss anything, right? If you are focusing on only this session from isomerism, if you are dependent on only this particular lecture for isomerism, you don't need to watch any other lecture, and that's my promise to you. Okay, that's my promise to you. Now she is finding it easy because she has done it 3 to 4 times. I think Nancy, you need to recall that time when you were doing this for the first time. She was like, "Oh my God, ma'am, I am not able to understand." Last one. Okay, last one, bacha. So these are the isotopes. So this is the third isotope of hydrogen. This is the first isotope of hydrogen. This is molecular mass 1 and this is molecular mass 3. So this is higher molecular mass. So that is why this has higher molecular mass will get the more priority in case of isotopes. And that is why this is number 1, this is number 2. This is 18 and this is 16. More molecular mass, so number 1 priority. Less molecular mass, so number 2 priority. As this is different, opposite to each other, so the answer is E. Okay. So now let us understand this. Very, very nice question. Very nice question. Let us see. Okay. Let us see this question. Here you met carbon. Here also you met carbon. Now double bond O means 1 O and 1 O. Okay. See, if I am writing anything like triple bond H, that means H, H and H. When you are applying CIP rule, always remember this thing. Triple bond H means single bond, single bond, single bond H 3 times. Double bond H means H and H. Double bond H means 2 times single bond H. Triple bond H means 3 times single bond H. Double bond O means 2 times single bond O. Understood this thing? When you are applying this rule, always remember this particular thing. Right? So now let us do this thing. Here you met carbon and carbon. Now this is, let us assume this is carbon number 1, this is 2, this is 3, this is 4. Right? In this case, you have C, O, O and H. This carbon is attached to 2 oxygen and 1 hydrogen. And this carbon is attached to 2 hydrogen and 1 oxygen. So which has highest priority? Which has highest priority? The one which is attached to two oxygen will have higher priority because oxygen has more atomic number. So that is why this will be given number 1 priority and this will be given number 2 priority. Right? Similarly with this case, we have this carbon that is attached to this carbon. Right? So that is, it is attached to number 1, number 2, 3 carbons. Triple bond carbon means it is attached to single bondedly 3 times to carbon. Okay? So now this is attached to 1 hydrogen, and double bond carbon means it is attached to 2 carbons with single bonds, right? So that means C and C. So that means it is attached to 3 carbon and it is attached to 2 carbon. So it will have higher priority because carbon has more atomic number and here the number of carbons are more. So that is why this is 1 and this is 2 and hence the answer is Z. Okay, hence the answer is Z. Okay, understood everyone? Understood everyone? Perfect. Okay, let us do another example. You can clearly see this is a very simple case. As you know, this is carbon and this is fluorine. So it will have number 1, it will have number 2. Right? And this is carbon, this is hydrogen, number 1 and number 2. And the answer will be Z. And the answer will be Z. Okay? Perfect everyone. Are you able to understand? Are you able to do the questions? Are you able to do the questions related to this? Yes? Yes. Hypothetical structures you have to make. Double bond means 2 times single bond. Triple bond means 3 times single bond. That's it. If you know this thing, the question will be solved very easily. Right? Okay? Understood? Understood? This is not EZ system. We have completed EZ system. Let us do anti-sin system. Sin and anti system. Okay? Sin and anti system. Let us do this system. We have till now completed structural isomerism. We have completed cis and trans. We have completed CIP rule. We have completed E and Z isomerism. Okay? Everyone till now? Any confusion till now? Very nice. This is oxime. Okay? Perfect. So now you have this reaction and here you get this oxime, right? And what kind of oxime is this? This is formed from aldehyde. So this is aldoxime. This is aldoxime, right? And this is formed from ketone. So this is ketoxime, right? This is ketoxime, right? Okay? Ma'am, when will you teach hydrocarbons? But after completing this isomerism will be done today. And after that, I'll start with hydrocarbons, right? Okay? Let us do this. So here you will have this thing. This is ketoxime. This is ketoxime. Okay, that was aldoxime. Now, let us understand how to define anti or sin. Anti-sin. Okay, let us see. Now, as you all know, this OH and this hydrogen are what? This OH and this hydrogen are actually on the same side and here the OH and hydrogen are on the opposite side. So this means in case of aldoxime, this is very simple in case of aldoxime, if H and OH are on the same side, that means this is sin, and if they are on the opposite side, that means it is anti, right? That means it is anti, right? If on the same side, that is sin, on the opposite side, that is anti, right? That is anti. In aldoxime. Let us talk about ketoxime. Let us talk about ketoxime. For ketoxime, you can either write it as sin or either write it as aldo. Both cases you can write. So now let us see how can you write it as sin and write it as anti. Let us see. Okay. So, if you are thinking, just focus on this OH. If you are writing this particular structure as sin, so what is sin to it? What is sin to it? What is sin means? Same. Okay, anti means opposite. Right? Sin, not that kind of, not that wala sin. Okay, oh my God, you have done some sin. Not that wala sin. Here the sin is means same side. Okay, OH on the same side, ethyl group is on the same side. So you will write sin, you will write sin, and this will be sin ethyl, then methyl, then you will write it ketoxime, ketoxime. This is ethyl methyl ketoxide, right? And about this thing, if you have to write anti, so this is OH and this CH3 is anti to it. So you will write it as anti, and what is anti to it? CH3 is anti, CH3 is the opposite to it. So you will write it as anti methyl ethyl ketoxide. Anti-methyl ethyl ketoxide. This is the right answer. Everyone in the chat box understood that? Yeah, she's auntie and that is synth. Auntie. We are talking about auntie. Okay, so who is auntie? We are talking about this auntie, not auntie. We are talking about auntie. Auntie G. Okay? Get up and dance. Right. Understood everyone? Sin and auntie clear to everyone? Everyone in the chat box, till now everything is clear to you? Is everything clear to you? Everyone in the chat box? Everyone in the chat box? Everyone in the chat box? Tell me if that is clear to you. What is sin? How to define anti and sin? Right? For aldoxine, that was very easy. For ketoxine, both can be written. Just see, if you are saying sin, then see what is same side. And if you are writing it as anti and what is opposite to it, you will write it on the first position. That will be a prefix, and after that you will write the other alkyl group. Right? Okay, perfect. Now, let us see cycloalkane. Let us see cyclohexane. Okay. So, double bond is same as ring. Just collapse that ring and convert it into double bond. Okay, always see this as this thing. Always see this as this thing. Always see this as this thing. Okay, always see this as this thing. This is this only. Right? Always collapse the ring and imagine it as a double bond. That is the trick to understand this thing. Okay, and I'll tell you just few lines and you will be able to crack this also. Right? So what is the line? See, if the substituents, mark my words, if the substituent, I'm writing this for you. If the substituents on different positions, then that will show geometrical isomerism. Okay, that will show geometrical isomerism as these two substituents are on the different positions. So that will show geometrical isomerism. Okay, these will show geometrical isomerism. Right? These will show geometrical isomerism. This will also show geometrical isomerism. Even if the same substituents are on the different positions of the ring, that will show geometrical isomerism. Okay, ma'am, how can you say that? If I write it as double bond CH3, CH3, it will be like this, double bond CH3, CH3. You tell me this is actually hydrogen and hydrogen. Will this show geometrical isomerism? Right? No, this will show geometrical isomerism. Same way. So that is a trick to this. That how can you just quickly answer this question? Just always remember this thing. Always remember this thing. Substituents on different position, it will show geometrical isomerism. It will show geometrical isomerism. Right? Okay. So this will show geometrical isomerism, both of these. Next is a question like this. This is A and this is B. This is A and this is B. Now tell me, will this show geometrical isomerism or not? Will this show geometrical isomerism or not? Right? Okay? Perfect. Now, there are chlorine and bromine on the different positions. That means this will show geometrical isomerism. Okay? Even if the same substituents or different substituents are attached on the different positions of the ring, that will show geometrical isomerism, no matter what. Okay, so in this case, do not collapse the ring. Reason? Because double bond is already mentioned here, right? So what is this? This is the first case, right? This is the double bond. These two groups are different. Here we see CH2, CH2. Here we see CH2. That means the environment from here and here are same. The environment is same. What does that mean? That means on this double bond side, wait. It's not like this. It's not like this. एक minute यार. Just give me a minute. Okay. Yeah. So it was like this. Okay. It is like this. This is chlorine. This is bromine. And this is 1, 2, 3, 4. And this is actually 6. Okay. 1, 2. And this is 3, 4, 5. Okay. It is like this. Okay. So now here you can see this is carbon number 1. This is carbon number 1. And this is carbon number 2. On the same carbon, you need to find the different environment. And on the same carbon, you will find chlorine, and here you will find a ring. Here you will find bromine, and here you will find a ring. That means the environment is different here. So that will also show geometrical isomerism. This will also show geometrical isomerism. Okay? This will also show geometrical isomerism. Right? Okay? Now, what about this thing? What about this thing? Will they show or not? If the substituents are on different position, the same substituent or the different substituent are on the different position, it will show geometrical isomerism. We have seen that. If the same substituents are on the same position, it will not show geometrical isomerism. It will not show geometrical isomerism. Okay? So I'll write it here. If same substituent on same position of ring, then no geometrical isomerism. No geometrical isomerism. Okay? Always remember this while calculating, while identifying the geometrical isomerism or not. Okay? Okay, sure, bacha, you can go. Sure, you can go. But always watch the recorded session afterwards, okay? Do watch the recorded session afterwards. Clear? Everyone, clear to you? Now let us calculate the number of geometrical isomerism. Let us calculate the number of geometrical isomerism here, right? Okay? So, if the compound is asymmetrical, the formula will be 2 raised to power n. And here the n will be number of sides of geometrical isomerism. Number of sides of geometrical isomerism. Okay? And if the compound is symmetrical, then the formula will be 2 raised to power n minus 1 plus 2 raised to power p minus 1. Where p is equals to n by 2 if n is even, p is equals to n plus 1 by 2 if n is odd. Okay, if n is odd. That's it. You just need to apply these formulas and you will get the geometrical isomers. Let us do some examples. Guys, let us do some examples or not? Let us do some examples. Yes or no? Should we? Let us do some examples. Let us start some examples. Tell me, is this compound symmetrical or not? This compound is 1, 2, here single bond, here double bond. So that means this compound is asymmetrical. And for asymmetrical, you have 2 raised to power n. For asymmetrical, you have the number of GI will be 2 raised to power n. And what is n? N is the number of sides of geometrical isomerism. That means you have this double bond, you have this double bond. But out of these 2 double bonds, this has H and H attached to 1 carbon. That means this will not show geometrical isomerism. This double bond will not show GI. That means this is not the site of GI, right? And this is the site of GI because it has 1 hydrogen, 1 CH3, 1 hydrogen and 1 this ring, 1 this group, right? So this will show GI. So that means N is equals to 1 here. So that will be 2 raised to power 1 and the GI will be 2. And the GI will be 2 geometrical isomerism here, right? There will be 2 geometrical isomerism, right? Okay. Now, let us do the second example. 1, 2, 3, 4. Okay, single bond, double bond, single. That means this is a symmetrical compound. Now, if the compound is symmetrical, that means you have to apply that formula of 2 raised to power n minus 1 plus 2 raised to power p minus 1. Is it? Right? 2 raised to power n minus 1, 2 raised to power p minus 1 you have to apply. Let us calculate the number of GI sides. This is double bond, this is the double bond. Both are the sides of GIs, because in both the cases there are different groups on the same carbon atom of double bond, right? So that means n is equals to 2 here. Very good, bacha, very good. N is equals to 2 here. So n is even. If n is even, if n is equals to 2, what is p? That is 2 by 2, that is 1. So that is 2 raised to power 2 minus 1 plus 2 raised to power 1 minus 1, that is 2 raised to power 1 plus 2 raised to power 0, that is 2 plus 1, that is 3 geometrical isomers will be present here. Okay, how 2 geometrical isomers? Okay, so bacha, here as you can see the formula here for asymmetrical is 2 raised to power n. Okay, as you can see the formula for asymmetrical is 2 raised to power n. Okay, just apply that formula here, 2 raised to power n, and here you get n is equals to, this is not showing geometrical isomerism, no GI, and there is no side. Every double bond in that structure, all the double bonds that are showing geometrical isomerism, only that will be considered. Okay, here this double bond is not showing geometrical isomerism because this double bond has this hydrogen and this hydrogen. These two atoms are same. And when the two atoms are same on the same carbon of a double bond, that means they do not show geometrical isomerism. Okay? This shows and this doesn't. So n is equals to 1, 2 raised to power 1 is 2. Right? Okay? 2 raised to power 1 is 2. And here you have this formula and apply this formula here, you get 3 isomerism. 3 isomers. Is it clear? Is it clear? Is it clear to everyone here? Right? How I got this answer? Clear to everyone here? Right, bacho? Clear to everyone here? Clear to everyone here? Now we have completed 2 major things, that is structural isomerism and geometrical isomerism. So congratulations everyone. We have completed 2 major topics, that is structural isomerism and geometrical isomerism. We have completed that. We also know how to calculate the number of geometrical isomerism. Right? Okay. Symmetrical and unsymmetrical, how will I find? Beta dekho. Now you have double bond and from this side you have one single bond. Symmetrical means if this phone is symmetrical, if I can just cut it down into pieces and it will be equal halves. Now if you can cut this into equal half, that will be symmetrical. I can't cut it into equal halves, right? This is double bond here, this is single bond here, right? I can cut this into equal halves, right? If I cut one plane here, this will be CH double bond CH3. This will be CH double bond CH3. That means I can cut it into equal half. That means it is symmetrical. Okay? Perfect. Very nice. Very nice. Very nice. So, do you want a break for okay, I'll give you one question. Only then I'll go for break. Okay, I'll give you one question and there will be break for 5 minutes. Okay, after that we are going to start optical isomerism, where we are going to do RS configuration, DL configuration, apimers, then enantiomers, diastereomers. Okay, and we are also going to calculate what is racemic mixture, how to calculate optical isomers, optically active isomers, how to calculate enantiomers, how to calculate I think that's it. Racemic mixture, enantiomers, how to calculate optically active, optically inactive, and how to calculate total number of optical isomers. Right? Okay, all these things we are going to do in the next half. Okay, in the next half, all these things we are going to do. Right? And this is very important. This is also very important. Understood everyone? I think it will take 1 hour to complete all that, maybe 1 and 1.5 hours. Okay, so I think you all should rest for 5 minutes and I'll give you one question. If you want to solve something, and also go through this, okay? Just go through this whole lecture and see if you have any doubt. If you have any doubt regarding anything, just ask me after I come from this break. The break will be of 5 minutes only. I'll give you one question, okay? I'll give you one question that is, this is double bond. This is pH. Wait. This is CH, double bond. This is CH, single bond. This is CH, and then double bond. This is CH, and this is pH. Okay. Now calculate the number of geometrical isomers here. Calculate the number of geometrical isomers here. This is your second question. And for the first question, just calculate if it shows geometrical isomerism or not. This is C double bond C. This is Me. This is H. This is okay. Just show GI or no. Just show GI, yes or no. And this is the number of geometrical isomerism. And also third question also I will give you. In this 5 minutes, you have to calculate these questions, okay? You have to calculate these questions. I'm not going to make you free for any minute, okay? So this is the, you know what this will do? This will make you understand that till now, have you understood everything or not? Right? This is self-analysis. This is not to show me that you have understood or not. This is for yourself. You will be able to understand if right now, till now, I have any problem. You will be able to identify that. Okay? You can, I'm live here, I'm present here. So you can directly ask me, ma'am, I have problem in this particular thing. Right? Okay? So just answer, is this E or Z? Is this E or Z? You have this fluorine. This is okay. Right? This is E or Z. Answer this question and I'll be there in 5 minutes. I'll be there in 5 minutes. Okay? This is 57 now. This is 57. Is NCRT enough? No, NCRT is, I won't say enough, right? You have to do some things like these kind of stuff that is not clearly mentioned in NCRT. But okay. You don't need to refer to so many books. For inorganic, NCRT is perfectly enough. For organic chemistry, you need to practice so many things, right? So that I am doing that for you. And for physical chemistry, just stick to NCRT formulas and everything. And also do the practice. Do the practice. Okay? Perfect. So I'll be back in 5 minutes. Everyone do these questions. Okay? I'm going to ask you these questions. Okay, hi everyone. Can you see me? Everyone in the chat box. Everyone in the chat box. Can you see me? Welcome back after the break. Welcome back. Is my voice audible to everyone? Is my voice audible? Is my voice audible, everyone? Ooh. Where are the students? I'm searching for you all. Where are you all? I can see the cursor here. Okay, perfect. So, am I audible? Am I visible, everyone? Welcome back. Welcome back. Welcome back. So, have you done the questions here? You have taken the break, right? Perfectly ready for the next part of today's class, that is optical isomerism. A very interesting thing that we are going to do today. Ready for that? Yes. Audible, visible, perfect. Okay. Everyone have everyone joined in again. Okay. So guys, I'm starting the class. Yes, what you want to say, I'll reply to you definitely. So firstly, let us see the answers to these questions, okay? The answers to these questions. So question number one, does this show geometrical isomerism or not? Geometrical isomerism, yes or no? Everyone in the chat box. Yes, no, yes, no, yes, no. What kind of yes, no? Okay. So this is double bond, this is methyl, this is hydrogen. So these two groups are different, right? And here also you see CH2, CH2. But here you see CH2 and here you met methyl here. So here the differentiating factor has been there, is introduced at this point only. So that means these two groups are different as well. So this will show geometrical isomerism. So we'll write it as yes, shows geometrical isomerism. Second is this one, this will be same, just like this is symmetrical. This is symmetrical and this has n is equals to 2. Right? So this is same as this one. This is same as this one. This is symmetrical and has n is equals to 2. The answer will be 3. I've only replaced CH3 with phenyl group. That's it. Okay? So the answer is n is equal, geometrical isomerism is equals to 3. Gi is equals to 3. Okay? Geometrical isomerism will be 3. Right? On the third part, you have this is the first priority and this is the second priority. And here we have C, which is bonded to 2 oxygen and 1 hydrogen. Here carbon is bonded to 3 hydrogens. So that means this will get the number 1 priority and this will get the number 2 priority. And hence the same side, so it will be a Z, it will show Z isomerism. Okay? Very good. Very nice. Very nice. So let us start optical isomerism. Let us start optical isomerism. So what happened to what was the idea of optical isomerism? So this is actually a light that is reflecting in all the directions. In all the direction, and we pass it through nickel prism. This is the nickel prism. We pass it through nickel prism, and through this nickel prism will have a plain polarized light. Okay, so this is only going in one direction. This is plain polarized light. Plain polarized light. Okay. Now, after this, what is the idea of optical isomerism? So what they do is, they take the plain polarized light and then they take a compound. And they pass this. They take a compound and they pass this plain polarized light through this compound. Okay. They take their desired compound. They have to check if this particular compound is optically active or this is optically inactive. So how they will check this, right? So what they do, they take a plain polarized light and they start passing it through this compound. So now there are 3 cases that can be seen from this. First case is that this light will not get rotated anywhere. There is no change in the light. No change. And second case is it will rotate clockwise. Clockwise is like this. It will rotate clockwise. Right? So it will rotate clockwise. like this. So it rotates clockwise. We will write it as rotate clockwise. And third case is it will rotate anti-clockwise, opposite to the clock, right? So that is anti-clockwise. This is anti-clockwise, anti-clockwise. So these are the three cases. Now, if it is having, this light is having no change, that is called optically inactive compound. That is called optically inactive compound. And if the light is getting rotated either clockwise or anti-clockwise, that is called as optically active compound. And this is called as optically active compound. Okay, this is optically active compound and this is optically inactive compound. Everyone understood this? Now you have a plain polarized light. If it is not changing the direction, that is inactive. It is rotating clockwise or anti-clockwise, it is optically active compound. So this was the experimental stuff. Now, today we are going to talk about how can we find the optical activity or inactivity from just seeing the structure without doing the experiment. Okay? Without, why you are not active on the chat box? What happened to you? What happened to your energy? Everyone in the chat box, what happened to your energy? My energy is still like this much. What happened to your energy? You can grab a tea and a coffee. Okay? But the energy should be high. Always keep smiling and the energy should be high when you're studying, no? The energy should be high. You should feel very positive. Okay, I'm learning something new. I'm learning something. Yeah. Okay, I'm gaining some knowledge. You should always feel happy about it. Okay. So now, as I told you, if there is no rotation, then that is optically inactive. And if there is rotation, that is optically active. Either clockwise or anti-clockwise. So now, if the rotation is clockwise, then we say that is dextro. And that is represented by small d. I'm not talking about capital D or capital L. I'm here talking about small d. Okay? You want to be a doctor? Everyone, do you want to be a doctor? Everyone wants to be a doctor. Same case, DR. D means right. D means dextro. R means right. And if you become a doctor, you will be very positive. So that is why dextro is positive. That is why dextro is positive. Seriously listening, ma'am. We are totally into this. Okay, perfect. Okay, you're totally like, when you're watching a movie, no, you're like, okay, don't disturb me. I'm totally focused on that movie. Okay, perfect, ma'am. Yes, we are getting it, ma'am. Yes, go, ma'am. Yes, we are doing this. Perfect. Okay, yes. If you're clearly watching this, perfect. Okay. So now clockwise is positive, that is dextro, and anti-clockwise is levo, that is levorotatory, and this is represented by small l, not capital, small l, and this is represented by minus sign. It has nothing to do with capital D, capital L. Nothing to do with R and S. Nothing. They are just different terms. This is just experimentally. Right? This is identified experimentally. What is clockwise? Dextro, anti-clockwise, levo. Doctor, D for dextro, R for right. When that is rotated right on the right side, that means clockwise. That means it is dextro, and dextro is positive. Okay, and dextro is positive. Right. Okay. Next is. Now we know this. Now let us understand how can we identify the optically active compound just by looking at the structure. How can we identify an optically active compound? Let us see that. So now, there are 2-3 cases. Okay. So firstly, let us see the symmetry. If the compound is asymmetrical, that means it doesn't have plane of symmetry. POS means plane of symmetry. It doesn't have center of symmetry. Nothing. No plane of symmetry, no center of symmetry. That means that compound is asymmetrical. Right? There's no symmetry. If I divide myself like this, I'll be symmetrical. No, I'll be symmetrical. Half nose here, half nose here, one eye here, one eye here, one ear here, one ear here. I'm symmetrical, right? Okay. So plane of symmetry, center of symmetry. That is, if it doesn't have any of this, that is asymmetrical, right? If the compound is asymmetrical and it has at least one chiral atom, We'll understand all these things in detail. What is chiral, what is POS, what is COS. Okay, firstly let us understand the condition. If it doesn't have any plane of symmetry, center of symmetry, but it has at least one chiral carbon, that means it is optically active. That means it is optically active. Optically inactive, it means if it has any symmetry, whether it's plane of symmetry, it's center of symmetry. If it has symmetry, then it has all the carbons that are achiral. Then it is optically inactive. Understood, everyone? Optically inactive, no chiral carbons. Here at least one chiral carbon. Here no symmetry. There should be at least one symmetry. Okay, one symmetry. Understood, everyone? Now let us see what is plane of symmetry firstly. So there were so many terms to identify the symmetry of this. We'll just focus on plane of symmetry and center of symmetry for your particular topic, right? So let us see plane of symmetry. Let us see firstly plane of symmetry. This is all, optical isomerism is all about imagination. You have to imagine things, right? You have this bottle, and if I'm dividing this bottle into two halves, it will be, okay, plane of symmetry. Plane means there's the plane, there is a notebook that is actually, for example, this is the plane. Okay, plane is in 3D. If this plane is something, if this iPhone, it is not iPhone actually. If this phone can cut this bottle, okay, if I'm sliding it this way and this can cut this bottle, this is my plane and this is that object. If this can cut it into equal half, that is plane of symmetry. If I'm passing this plane like this cannot cut it into equal halves, right? In this way, there will not be equal halves. That is the top, that is the bottom. They are not actually equal to each other, right? The shape is totally different from bottom and from the top, right? So that means these are not equally divided. That means this is not the plane of symmetry. This is the plane of symmetry. Okay, this is the plane of symmetry. So now let us see the plane of symmetry in all of these. For A, you have this triangle. Always remember this one thing. Always remember this one thing. Now I have one jugaad to make you understand this. Just, yeah. Let us see that jugaad, okay? Now these are the two chalks, right? Now let us assume these are the two atoms. Okay, these are the two atoms. So now these atoms are on this first position. Okay, these are actually like this. Now, how will you assume these atoms? If they are on the same position, you will not assume this like this. This is not the assumption. Okay, this is not the correct assumption. This will be like this. Okay, they are actually in 3D like this. So if I am able to cut this, if I am passing a plane like this, I can cut this chalk into two equal halves. And atoms, you know, they are circular in shape. So if you are having two balls here, I don't have balls right now, right? So what do I do? I only have chalk. I'm a teacher, no? I'm not a kid. I don't play with balls right now. Okay? So this is the chalk. So this chalk, as you can see, if I'm passing the plane like this, I can actually cut this fluorine atom and this hydrogen atom into two halves. So that means if I'm passing this plane, I can't say there is no plane of symmetry. There will be plane of symmetry because actually I'm cutting that chlorine atom into two. I'm cutting that hydrogen atom into two equal halves. So there are symmetry. There is a symmetry present there. It's not happening like this. Chlorine atom will be here and hydrogen atom will be there. Actually, one is towards your side and one is toward my side. Okay, one is solid wedge and one is dash wedge. That means I can actually cut them into equal halves, right? So that means there is plane of symmetry present here, right? So now, similarly with this, you have bromine atom, you have hydrogen atom. Similarly like this, you have these two chalks, right? This is bromine atom, this is hydrogen atom. Just pass a plane here and you can see bromine atom equally half and this hydrogen atom cut into equal halves, right? So that way you can say that this is also, here also plane of symmetry is present. And what about this? These atoms are same, right? But even if they are different, we can easily cut them into equal halves. So that means Plane of symmetry is also present here, 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 and also here. Plane of symmetry is present in all these cases. Okay? Okay? You will never face any problem in understanding the plane of symmetry. I don't have as such any other jugaad here to explain you plane of symmetry, but I have this one thing. That can make you understand the plane of symmetry, okay? That can make you understand the plane of symmetry. I don't know what is this. No idea what is this. Okay, so can you see this? Can you see this? This is like atom. Okay, this is like an atom. Okay, this is like atom. If I am dividing this, if I am passing a plane, it will be cut half and half. Similarly, with these chlorine and hydrogen atom, they are placed like this, not this and this. They are placed equally like this. One chlorine atom here, and just backwards you have another hydrogen or any other atom. If you pass a plane, this will be cut into half, and the other atom on the backwards will also be cut into half. Okay, everyone in the chat box? Ma'am, will you complete the full isomerism? Yes, bacha, I'll complete the full isomerism today itself. Okay, I'll complete the full isomerism. Just one topic will be left. That will be conformers of ethane. Okay, I'll complete that in hydrogen only. Okay, that is mentioned in hydrogen chapter. So we will complete that in hydrogen. Okay, understood? I have no idea what is this. No idea. Something related to earphones or something. I don't know. Okay. So this is A, this is B, and this is C. Let us see the plane of symmetry present here, right? Okay. So if I cut this, if I pass a plane here, this will cut it into equal half. This is also downwards. This is also downwards. That means this will cut it into equal halves. This plane will cut it into equal halves, right? If I talk about this and I pass the plane like this will not cut this into equal halves. Why? Here the bromine is downwards. Okay, it is facing downwards. Okay, here the bromine is downwards and here the bromine is upwards. If this is the plane, one bromine atom is downwards and one bromine atom is upwards. Okay, yeah. Okay, one bromine atom is upwards and one is downwards. That means I cannot cut it into equal halves. This cannot be cut it into equal halves, so no POS. No POS, there will be POS present, there will not be any POS. Right, if I talk about this thing, what about this? Will there be any plane of symmetry or not? Will there be any plane of symmetry or not? Let us understand that. Let us understand that. You have a bromine atom. Everyone understand? Okay, ma'am, but if we pass this plane of symmetry, this bromine atom, this will be cut into equal halves. This will be equal half. This bromine atom, just imagine a cricket ball, okay? You can cut it into equal half, right? Similarly with this atom, similarly with this bromine atom, you can cut it into equal half if you're passing this plane. And this particular chlorine atom is on one side and there is also one chlorine atom on the similar position on the other equal half. Okay, so this also shows plane of symmetry. This also shows plane of symmetry. Understood everyone? Understood everyone? Why this is showing plane of symmetry? Because this bromine atom, just like a cricket ball, we can pass a knife there and cut it into equal half. Similarly, we can cut this bromine atom into equal half, and hence there will be a plane of symmetry present here. Okay? Okay? Yes? Okay, perfect. There will be plane of symmetry. So till now, is there any issue? Is there any problem in the plane of symmetry? Is there any problem in plane of symmetry? If anyone has any problem till now, please comment down. Please write it in the chat box. See, we are not actually present in the offline centers, right? This is not an offline class. In the offline class, I can easily predict it by your facial expressions. Okay, this person has not understood. This student is not able to understand. So I'll just focus on that kid. Okay, so let me answer you this. Okay, so right now I'm not able to see your expressions, right? So only I can identify is by you typing it in the chat box that ma'am, we have understood this, ma'am, we have not understood this. Please explain this again, right? Okay, yes, perfect. Okay, so I'm trying my best that this feels like an offline session only, offline class only, right? Okay, so guys, this is the first part, second part, third part. In the first part, if I pass the plane of symmetry like this, I can cut it into equal half. This bromine atom and this bromine atom will be cut it into equal half. Even if there is one bromine and one chlorine atom, even if there is one bromine and chlorine atom, even then there will be a plane of symmetry present, because this bromine atom and this chlorine atom, like these two chalks, will be cut into equal half. One bromine and here will be chlorine. This is forward, this is backward. I'll cut it into equal half. Both the bromine and the chlorine atoms. Okay, so there is plane of symmetry present here, even if I have one bromine atom and one chlorine atom in this case, right? And here, if we cut it, if we pass a plane of symmetry like this, there will be equal half. This will be equal half. What about this? What about this bromine and this chlorine? What about this bromine and this chlorine? Okay, what about this bromine and this chlorine? This bromine and this chlorine, they're actually, how they are present, this is the plane, this is present downward. So I'm cutting it like this. This bromine atom will be cut into equal half, and this chlorine atom will also be cut into equal halves. Okay, this bromine, and just imagine it like cricket ball. Okay, there's one cricket ball here, there's one cricket ball here. Okay, and I'm passing the plane like this. Okay, there's like one cricket ball here, one cricket ball here. I'm passing the plane like this. So I'm cutting it down into equal half, both the bromine and chlorine atoms. So that is why one POS is present here. Okay, one POS is present here. There are POS present, because see, how do you imagine this? See, this is one plane. This triangle is actually this. This triangle is actually this. And this is one bromine atom. This is one chlorine atom. Okay, this is one bromine and this is one chlorine. This is the triangle. Okay, these chlorine atoms are already equally divided. What about this bromine and chlorine? I'm passing the plane like this. I'm passing the plane like this. Okay, I'm passing the plane like this. It means that I'll be able to cut this bromine and this chlorine atom both into equal half. So that means this will be divided into equal halves. There will be plane of symmetry present here. Understood this or not? Understood this or not? Sheshadri, Pratibha, Medico, tell me, have you understood this or not? Okay, understood. Are you able to imagine this? Are you able to imagine this? Are you able to imagine this? I'm just looking for anything that I can actually make you imagine these things. Okay. Understood? Understood? Perfect. Perfect. Okay. So now let us understand the POS, plane of symmetry of this particular compound. If I am passing the plane of symmetry here, this is not possible. I can only place plane of symmetry here and I'll be able to divide it. But here also, if you are passing this plane of symmetry, there is chlorine atom here and this is the chlorine, this is bromine and this is the chlorine atom here. You are not able to cut the bromine and chlorine into equal half. So this half will be different, this half will be different. So there is no plane of symmetry present here. There is no plane of symmetry present here. Everyone in the chat box, please let me know if you have understood this part, because this was a little imaginative part. Okay, you have to imagine this thing. Okay, this is one bromine atom, this is one chlorine atom. You are cutting this. This is the triangle. This is the triangle. For example, see. For example, this is the book. This is that ring. This is that ring. Here is that ring. One carbon and one. Okay, this is that plate. And the atom is like this. This is one bromine atom. This is one chlorine atom. And what I'm doing, I'm passing the plane like this. I'm passing the plane like this. That means I'm cutting this bromine atom and this chlorine atom into equal halves. And there is one chlorine atom here. There is one chlorine atom that is already divided into equal halves. But when I'm passing this from, for example, at this corner, I have one bromine atom and one chlorine atom. So I'm passing it like this, cutting the bromine atom, cutting the chlorine atom into equal halves. Okay, perfect, perfect. Okay. Yes. Now, let us see. This is very easy. This is very easy. Very easy. No imagination needed here, right? Just cut this into equal half. Just cut this into equal half. Okay, this is CH2OH, CH2OH, H, OH, OH. That means POS is present here, right? Just cut this, cut this. This is CH2OH, CH2OH. This is OH and this is hydrogen. That means these are not the equal halves. These are not the equal halves. So that is no POS. No POS. Okay, no POS is present here. Okay, perfect, perfect. Let us do this. Let us understand the concept of allenes already. Now, again, imagination is needed here. Okay, but okay, I have my hands, okay? So I'll make you understand by moving my arms and all that. Okay, this is the jugaad I have. Okay, so actually this is very interesting to understand this way, right? Okay, so let us understand allenes. Now you know that when the double bond are on the adjacent positions, like double bond, then double bond, then double bond, then double bond. If the double bond are continuous, they're on the adjacent position, what happens is, as you know, pi bond is formed by sideways overlapping. So that means there will be so many sideways overlapping here, so many sideways overlapping here. That is why in this case, repulsion occurs. In this case, repulsion is present, steric hindrance is present, and that is why one double bond, if that is present in this plane, other double bond will be present in this plane. Okay, that will be perpendicular to each other. Okay, so for example, this is one double bond, this is another double bond. They are adjacent to each other. So what will happen in this case? So because they are adjacent to each other, because of repulsions, these two double bonds that are adjacent to each other will be perpendicular to each other. Okay, they will just switch. Okay, this double bond will be on this plane, and this double bond will be on the perpendicular side. Okay, if this is in xy plane, this will be in yz plane. The plane will be different. Okay, this will just be perpendicular to the adjacent double bond. Okay, understood? That will be like this and this, and it will be perpendicular. So all the adjacent double bonds are perpendicular to each others. Okay, adjacent double bonds are perpendicular to each others. That means if you are writing this, if this is in this plane, if this is in this plane, this is chlorine and this is bromine. Okay, this is chlorine and this is bromine. So now this double bond has switched the position. These are this small finger and this thumb are the substituents, and this small finger and this thumb are the substituent. Okay, understood? Substituents, are you thinking? Okay, these are the substituents. This small little finger and this is the substituents, right? Okay, so it's in the same plane. As these are adjacent to each other, so it will be perpendicular. So that means if this particular, these two substituents are on the same plane, then this will be on different plane and this will be on different plane. So that means I can write it as, if these two are on the same plane, I am writing this on as a simple line. So this one will be a solid wedge and this one will be a dashed wedge. Understood this? Okay, these are the substituent, and this is on the same plane. This will be, one will be outwards, one will be inwards. Understood this? These are the two substituent, these are the two substituent. These are on the same plane, represented by solid line, normal line, and this will be represented by solid wedge, and this will be represented by dash wedge. Understood, everyone? Understood? Katie, she's saying ma'am is teaching us like this. Ma'am is teaching us like this, like as if she is teaching us thumb rule, right? Okay? Understood, everyone? Understood? Okay. So everyone who don't know what is jugaad means Indian hacks, okay? Desi hacks, Indian hacks. Okay, bachcho? Okay, guys? Everyone understood this? Okay, so now let us see how you will define the optical activity and inactivity of this. This is the trick. As you all know, I have trick for everything. I have chart for everything for you. I have concluded everything for you. Okay, so this is the conclusion that I have for you, right? So if you have even number of double bonds, then what you will say? Okay, if you have odd number of double bonds, just simply say inactive. If you have odd number of double bonds, simply say inactive. If you have even number of double bond, say same. Okay, I have written it in Hindi, so I'll write it in English. Same on different, same on same, same on same. Okay. So if you have even number of double bonds and if you have same on different means if you have same substituents, if you have same, just a minute, I have to translate it into English. Same, same, different. Okay, if you have different substituent on same carbon, I'll write it something like this. Okay, I'll just let me correct this thing because that is actually in Hindi. So I'll write it in English. write it as same substituents just write it as this. Okay, write it as this. Okay, yes, this is the correct trick for English students. Okay, for students who are teaching in English. Okay, so now if you have odd number, then just write it as inactive. It is optically inactive. If you have even number of double bonds and if you have different substituents on same carbon, then it is optically active. If you have same substituents on same carbon, that is optically inactive. So this can only be optically active if you have even number of double bonds and that too you have different substituents on same carbon. Okay, different substituents on same carbon. Understood everyone? Different substituents on same carbon. Let us do the questions here. This is the first question. This is the first question. As you know, 1, 2, 3, 4. We have 4 bonds here. 4 bonds means we have 4 even. We have even number of double bonds here. And if you have even number of double bonds, just see on the same carbon atoms, you have same number, same substituent. Okay, if even on one carbon atom, you have same substituent, that means it is optically inactive. It is optically inactive. As you can see this from here, if you have even number, same substituents on same carbon, that is optically inactive. Same substituent on same carbon, that means optically inactive. Understood everyone? Understood everyone? Understood? So now you have this 1, 2, 3. Here you have three number of double bonds. That means odd number of double bonds. And odd number of double bonds correspond to inactive. So directly write it as inactive. So directly write it as inactive. Okay. This will be inactive. Understood everyone? Understood? Where everyone just run away? What happened to you all? What happened? Why everyone has run away? I tell you, there are so many less students who have actually the patience to watch like till the end. Right? Okay. So now this was the same cases with spiro compounds. The same cases with the spiro compounds. Right? Like in double bond, just consider this as double bond only. Okay? Like that double bond, this is also double bond. Here also due to repulsions, one is in the first plane and second is in the perpendicular plane. If this is in this plane, this will be in this plane. If this is in this plane, this will be in this plane. The planes will be perpendicular to each other. These will be perpendicular to each other. So now similarly, if you have odd number of spiro rings, that means it is optically inactive. This is actually even number of spiro rings. So this is even number of spiro rings. If you have even number of spiro rings, then what you need to do? If you have even number of spiro rings, just go and see. These has same carbon and this has different substituents. This also have different substituents. And if you have different substituents on the same carbon, that means that is optically active. That is optically active. Write it as optically active. Okay? Write it as optically active. Next is there are 3 rings. There are 3 spiro rings. So let us write it as odd number of spiro rings. So that write it as inactive. Odd number of spiro rings means that is inactive. Same from this chart. From this chart, odd number of this means inactive. If you have even number, same substituent, same side, inactive. Different substituent, same side, that is optically active. This is the only case that is optically active. If you have even number and you have different substituents on same side. Okay? Got it everyone? Everyone in the chat box? Everyone in the chat box? Understood? Understood everyone in the chat box? Everyone in the chat box? Understood? Understood? Perfect. Okay? Okay, so now, bacha, let us see the 2 phenyl rings. That means biphenyl. Biphenyl means 2 phenyl rings are attached to each other. So now, if you have simple phenyl rings attached to each other, then they will be on the same plane. Simple phenyl rings will be on the same plane. But if the substituent attached here, are very big, Like they are very large, very big. So there will be repulsions and they will switch the plane, and one will be in this plane, other will be perpendicular to it. Okay, if the substituents are large. Okay, so now let us discuss. Same way you have to answer this question. Okay, there is no condition of even and odd because this is biphenyl. Every time the rings will be even, right? This is already biphenyl, 2 phenyl rings. Okay, so just see, on the same side you have different groups, on the same side you have different groups, right? Okay, on the same side you should have different groups. Same side, different groups, same side, different groups. That means this is optically active. This is optically active. Just always remember this one condition. Same side, different means optically active, and that should have even number of double bonds or rings. That's it. Okay, that's it. This is a trick to solve such questions. Now, on this side it has CH3 and H. On this side it has, this is also CH3, methyl means CH3, and this is also CH3. On this side it has same substituents. Same side, same substituent. That means same side, same substituents means it is optically inactive. It is optically inactive. So the summary is, if there are odd number of double bond or rings or whatever we are talking about, double bond or rings, then it is optically inactive. If they are even number, then just see on the same side, if you have same substituents, then that is optically inactive. On the same side, you have different substituents, that is optically active. That's it. And you will find the answer to it. Okay, everyone in the chat box understood this? Everyone in the chat box. Okay, perfect. So now let us see center of symmetry. Like you are sitting in the center. You don't know this circle. Circle is very symmetrically it has a center of symmetry, right? Why? Because from this point, if you go here, 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 the radius is always the same. That means it has center of symmetry. So now let us find out center of symmetry in all these things. Okay, so in this point, this is point 1. If you move from this side, we get a point. If you move this way, we get a point. Okay, no. We just need to find the center of symmetry this way and this way. Always go first direction, backwards, forward, backward, forward, backward. That means if this is the point that you are checking, go forward and go backward. That's it. If you find the same kind of environment, then that has center of symmetry. If you do not find the same environment, that it does not have the center of symmetry. Okay. This is the center point. If you go this way, you find a carbon. If you go this way, you do not find any carbon. Okay. Now, if you go this way, you find a carbon. If you go this way, you do not find any carbon. If you go this way, you do not find any carbon. In this way, backwards, you find a carbon. Always go forward and then backward. Forward and backward. And in forward and backward, if the environment is same, then there is center of symmetry. If the environment is not same, there is no center of symmetry. Okay. So now let us see the center. There is no center of symmetry here. No center of symmetry here because forward and backward, the environment is not same. The environment is not same. Now at this point, this is the center. This is the center. Let us go forward. You do not find any carbon. And backward, you do not find any carbon, right? Just go forward here. You find a carbon, and backward also you find a carbon. Here, forward you find a carbon, backward you find a carbon. That means center of symmetry is present here. That means center of symmetry is present in this structure. Okay, center of symmetry is present in this structure. Okay, everyone, understood this? Understood this? Perfect. Perfect. Now, have you understood the center of symmetry? Just 2 examples. I'll take another example. I'll take one more example of this. Let us take one more example. That is this ring. Okay, that is this ring. Now let us see the center of symmetry present here. This is the center. If you go this way, you find a carbon. This way you find nothing. This way you find a carbon. 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 But this way you find a carbon and backwards you do not find a carbon. That means there is no center of symmetry present. So we'll write it as no COS. Okay. No COS will be present here. Okay. Perfect. Now, odd number of rings usually do not have center of symmetry. Okay, odd number of rings do not usually have center of symmetry. Now, let us understand what is a chiral carbon. Okay, what is a chiral carbon? What is a chiral carbon? So, chiral center is something that is sp3 hybridized, first condition. Second is 4 different groups should be attached to it. A chiral center is that which is sp3 hybridized and it has 4 different groups attached to it. Okay, and 4 different groups attached to it, that is a chiral center. Let us understand this with the help of examples. Okay, so now this is your turn. Everybody active in the chat box. Everyone active in the chat box. Everyone, don't do this, okay? Be active in the chat box. Everyone, okay? Be active in the chat box, bachcho. So that I can actually feel that we are, interacting with each other. I can also understand that you are also, understanding what I am saying. So now in the first part, let us try to understand how many chiral centers are present here. In this case, you have 3 hydrogen atoms, right? This is methyl, 3 hydrogen atoms. We need all the 4 groups different. So this is not chiral center, right? This is also not chiral center. 2 hydrogen atoms are same. 2 hydrogen atoms are same, not chiral center. All these 3 are not chiral centers. What about this thing? What about this carbon? Now this carbon has 1 chlorine, has 1 different chain, and this is 1 different chain. This is ethyl and this is propyl. Propyl chain, ethyl chain, 1 hydrogen and 1 chlorine. That means 4 carbon atoms are, 4 groups are different here. And this is sp3 hybridized. So this is a chiral center. This is a chiral center. Okay, this is a chiral center. Now what about this B? You talk about this carbon atom, this group is different and this group is different. Why? Because it is carbon bonded to single bond. This is carbon double bond bonded. Right? This is bromine and here one will be hydrogen. That means this is a chiral center. And what about this? This is sp2, no chiral. sp2, no chiral. sp3, but this has 2 hydrogens, so no chiral. sp3, but 2 hydrogen, no chiral, 2 hydrogen, no chiral. Right? So only 1 chiral center is present here. Okay? Only 1 chiral center. Ma'am, third C is chiral. No, this is also chiral. This particular carbon is chiral here. This carbon is chiral here. Okay, this carbon is chiral here. This carbon is chiral here. Let us see about the third. Okay, let us see if third is chiral or not. Okay, third is actually not chiral because this is sp2 hybridized, so it is not chiral. This is sp2 hybridized, so it is not chiral. This is sp3 hybridized. This is sp3 hybridized, but it has 2 hydrogens. That means here we have 2 same groups on the carbon atom. So we need all the 4 groups different. So that means it is also not chiral. So it is a chiral molecule. This is a chiral molecule. Okay. This molecule is a chiral. Right. Okay. Plane of symmetry is present here. This is a chiral. Right. Okay. Understood everyone? Understood everyone? Understood everyone in the chat box? Understood or not? Understood or not? Everyone in the chat box. Understood or not? Please kindly tell me if you understood or not. Otherwise, it feels like I'm talking to these walls. Why you all are deleting your messages? What happened to you all? Why you all are deleting your messages? Okay? I'm not able to understand. Okay? Please. In first 3 hours, you were so energetic. I need that energy again in this class. Okay? I need that energy again in this class. Same manner. Only then we will be able to complete this today's session. Right? Now all those students who are present here from the very start, just tell me in the chat box. Okay? Just tell me in the chat box. Everyone. Okay? Yes. Everyone in the chat box. What happened to you, bachcho? What happened to you all? What happened to you all? What happened to you all? Okay. Okay. So now I will be able to see your chats. Now I will be able to see only your chats. Okay. Right? Okay. Perfect. So now Pratibha, Nancy, Sanjana, Rupa. Yes, now I am able to see your chats. Otherwise, yes. In the starting due to offline class. Okay, perfect, perfect, perfect. Kavya, very good. Okay, so what is A part? What about A part? So here we have this sp3, 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 sp3. But all these carbon atoms are attached to two same groups, that is two hydrogens. So that means these are not chiral. And what about this particular carbon atom? This carbon atom is attached to one hydrogen and one chlorine. But this is also attached to one ring that is actually leaving to same environment. Here also you find CH2, 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 CH2. That means this carbon atom is attached to this same ring, the same group. That means we can say this is a chiral molecule. This molecule is a chiral. Okay, this molecule is a chiral, right? Okay. So now what about this thing? What about this thing? sp3, 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 sp3. Right? This is sp3, sp3, sp3. Now, this is 2 hydrogen, 2 hydrogen, 2 hydrogen, 2 hydrogen. So, all these are not chiral. This is not chiral, not chiral, not chiral, not chiral. What about this thing? What about this and what about this? Now, this is a very interesting question. Now, this carbon is attached to one hydrogen, one methyl group, and this is attached to one CH2, and here it finds one methyl. In this case, it finds one CH2. In this case, it finds one methyl. That means this particular is chiral. And also, this is attached to one methyl group, one hydrogen. And this is, it finds CH2. And this way, it finds one methyl group. That means this is also chiral. All the 4 groups are different here. Okay. So, B has 2 chiral atoms, right? Okay. Let us understand the third here. Okay. How many chiral atoms here? This is not chiral, this is not chiral, this is not chiral. Let us talk about this particular. This has one methyl group and one hydrogen. Here CH2, here CH2. Here 2 methyl groups, here ethyl. That means these things and these things, the environment is different. At this place, while walking from here to here, the environment is different. So we can say this is chiral. This is chiral. Okay. I am representing chiral as a star. Chiral is represented as a steric. Okay. This is as a star. Okay. Now, this is the carbon, but this carbon has 2 methyl groups that are equal, that are same. So, that means this is not chiral. Okay, this is not chiral. Okay, let us talk about this carbon. This is attached to one ethyl group, one hydrogen. And this is CH2, this is CH2. That means still now same environment. This step it has 2 methyl group, this step it has 1 methyl group. That means the environment has changed. So, hence the groups are different. Okay, so we'll say this is also chiral. So it has 2 chiral. It has 2 chiral. It is a chiral. Okay, everyone? Everyone understood that? This is chiral. This is a chiral. This has 2 chiral. This has 2 chiral. Right? Everyone understood that? Everyone in the chat box, have you understood this or not? Everyone in the chat box. Everyone in the chat box. We have till now completed 85 slides. 85 times. Everyone, very nice, very nice. Just clap for yourself. Very nice. Well done. I'm so happy for you. I'm so happy for you. I just need this dedication from you guys. I just need this dedication, okay? So now let us see the chirality, the chiral center here, okay? This sulfur, the hybridization of this sulfur, that is 1 sigma bond, 2 sigma bond, 3 and 4 sigma bonds. Do not calculate the pi bonds in the hybridization. Just calculate the lone pairs and sigma bonds. Okay. It has 4 sigma bonds. So it is sp3 hybridized. Okay. This is sp3 hybridized. And moreover, the bonds here. Okay. This is sulfur. This will be sulfur. Okay. Here the double bond O means that 2 groups are same. That means it is a chiral. This is a chiral. And what about this? What about this? What about this? Now here you see this is also sp3 hybridized. This sulfur is also sp3 hybridized. This is sp3. This is sp3. But now this is attached to one oxygen, one sulfur, one CH3, one OH. That means all the groups are different. So this is chiral. I'll write it as 1 star because this is chiral. I'll write it 1 star because this is a chiral sulfur and this is not a chiral sulfur. This is not a chiral sulfur. This is a chiral sulfur. This is not a chiral sulfur. Okay, everyone? Understood? Perfect. Till now, any problem? Till now, any problem about the chirality? Let us discuss one more question here. One more question of chirality. A perfect example, a very nice example, a perfect example. Let us see this. This is the A part and this is the B part. This is the B part. Okay. Now let us understand this. What is the hybridization of this nitrogen atom here? You all know if nitrogen is making 3 sigma bonds, that means it will have one lone pair here. Okay, so there will be one lone pair present here, right? There will be one lone pair present here, and lone pair is also included while calculating the hybridization. So that will be 3 sigma bonds. This will be 3 sigma bonds plus one lone pair, that is 4. And 4 accounts for sp3 hybridization. To all my new students, let me define this for you. If you have sigma plus lone pair, that is 4, then you have sp3 hybridization. If you have sigma plus lone pair 3, then you have sp2 hybridization. Sigma plus lone pair 2, then you have sp hybridization. Okay? Understood? Now, this has sp3 hybridization, right? But are these groups different? The hydrogen is different. This is CH, this is ethyl, and this is lone pair. Lone pair is also considered as a group only. Okay, so all the 4 groups are different here. So we'll say this is chiral. This is chiral. So this is chiral. Chiral nitrogen is present here. Chiral nitrogen is present here. What about this B? What about this B? Who is going to answer this question? What about this B? Now, this is a tricky one. Okay, this is something that if you have attempted this before, then you'll be able to answer this. If you have not attempted this before, then you will say that, okay, ma'am, this is also chiral. Okay, so let us see. This nitrogen, what is the hybridization of this nitrogen? What is the hybridization of this nitrogen? See, you have these lone pair here. It's like one nitrogen, lone pair, then single bond, then you have one carbon, then double bond, this carbon, right? So is this the case of resonance? Resonance, we have discussed lone pair, then single bond, then double bond. That defines the condition of resonance. That means this will take part in resonance. As I already told you so many times in aromaticity also, I told you that whenever there is the lone pairs are involved in the delocalization, they are involved in the resonance, we do not calculate them in while calculating the hybridization. What I have said, if the lone pairs are involved in the delocalization, are involved in the resonance, then we do not calculate it in the, then we do not calculate it while calculating the hybridization. Okay, so we will not include these lone pair. Okay, these lone pairs not included in hybridization. Cause of resonance. This is the WhatsApp language, okay? Because of resonance. Because of resonance delocalization. So this nitrogen is sp2 hybridized, and that is why it is achiral. And that is why it is achiral. Okay? And that is why it is achiral. Okay? Understood, everyone? Understood this or not? Perfect. Okay, perfect. Okay, I'm going to answer this question as achiral because ma'am is like, there's some twist in that. Okay, everyone, have you understood this concept? Why this was achiral? Because whenever the lone pairs are involved in the delocalization, we do not participate. Whenever they are participating in the delocalization, we do not calculate them while calculating the hybridization. Okay, perfect. Now let us do this. Okay, now what are mesocompounds? Let us firstly understand this. Mesocompounds, they have 2 conditions. Okay, firstly, there should be 2 chiral centers. The chiral center should be 2 chiral centers present here. Then it should have one POS. It should have plane of symmetry. But usually we say that plane of symmetry and achiral is optically active, right? But here we are saying, optically inactive, right? But here we are saying the POS with 2 chiral centers defines for optically inactive, and those compounds are called mesocompounds. Okay, if it has two chiral centers, one plane of symmetry and a plane of symmetry, and that is called a meso compound, and meso compounds are optically inactive. Okay, meso compounds are optically inactive. Let us see an example of that. Let us see an example of that. This is the meso compound. As you can see, the plane of symmetry here is this. Okay, this is the plane of symmetry. So plane of symmetry is present here. What about the chirality? This is the OH, this is the hydrogen, this is the CH3. And this whole group is different. So this is chiral, right? This is also chiral, hydrogen, OH, CH3, and this whole group is different. So this is also chiral. So it has two chiral atoms, two chiral centers, two chiral centers. So that means this is a meso compound. That means yes, this is a meso compound. Okay, everyone understood this? Everyone understood this or not? Everyone in the chat box. Now, what is a racemic mixture? What is a racemic mixture? Let us understand that. Okay, racemic mixture is when you have 50% retention, 50% retention, and you have 50% inversion and 50% inversion. Okay, like if 50% of the product is same, the stereochemistry is same as before, that is retention. If there is inversion in the stereochemistry, the solid has the forward has come to backward and backward has come to forward, that is inversion. Okay, if there is 50% retention, 50% inversion, that is a racemic mixture. Okay, that is a racemic mixture, right? Then what is resolution? What is resolution? So resolution is something, if you have a beaker and you have both DL and configuration here, and you have DL and both dextro and levorotatory both in this beaker, right? Now, if you separate these beakers, if you have one beaker of D configuration, not configuration, if you have one beaker of D rotation, dextro rotation, and one beaker of levo rotation, then we say we have resolved this. Okay, we have done the resolution. Okay, we have separated these two, dextro into another and levo into another. We have separated these two things. Okay, then we say there is resolution. Okay, then we say we have done the resolution. Okay, understood? Okay, understood everyone? Understood or not? Understood or not? Understood? Yes. Okay, now just give me 2 minutes. I'll be back in 2 minutes, and after that we are going to do RS configuration, and then DL configuration, and then some little definition, and that will take 1 hour. Okay, that will take 1 hour. It will take I think today we'll finish the lecture by 9 o'clock. Okay, are you all ready for that? Are you all ready for RS and DL configuration today itself? Do you want to complete today itself? Just give me 2 minutes. I'll be back. Okay, I'll be back in 2 minutes just. Okay, perfect. Okay, are you ready to do that today? Can I expect you staying here for one more hour? Will you stay here for 1 more hour? Yes. Do you want to see yourself as a topper of NEET? Yes. So I want you here even after like for 1 more hour. Okay, perfect. Everyone in the chat box. Everyone in the chat box, tell me. Everyone in the chat box. I'm waiting for your replies. Okay, I'm waiting from your replies. I'm waiting for your replies, guys. I'm waiting for your replies. Okay, ma'am. Rupa is saying okay. And what about the others? What about others? What about others? I'm going to take the class only if you are interested, right? Only if you want me to take the class, right? If you want to complete the chapter, the isomerism today itself, I am here for you. Okay, if you're like, oh ma'am, we don't want to, we are not interested, okay, then I won't take the class. Okay, if you're like, okay ma'am, okay, perfect. Okay, so just give me 2 to 3 minutes, I'll be back. Okay, just 2 minutes. Okay, so I'm back. Okay. So my mom was inviting me for dinner. I said, okay, I'll have dinner only after completing the session. Right? Okay, everyone. But you can obviously have dinner side by side watching the class. But I would not prefer that, but you can still have. Okay? Okay, everyone. Okay, everyone. Who is hungry here right now? Who is starving right now? Just want to go and have dinner. Right? And who is eating side by side? Who is eating like okay, watching the live class as well as eating the dinner, right? Okay, everyone awake or you are actually sleeping? Awake? Yes, me, Nancy. Nancy is hungry, and who else is hungry? Who is starving right now? I just want to eat, man. Please, please finish the class. We are hungry. We want to eat something. Everyone in our home is eating dinner and we are here eating nothing. Right? Okay. Okay. So, okay. So let us see this. This is CIP rule. Okay. CIP rule. What is CIP rule? As I already told you about the CIP rule. As I already told you about the CIP rule. Okay, eaten anything after 11 a.m. because of continuous classes. Oh my god, don't starve like this. Just eat something side by side. I'm not going to, scold you because you are eating in the live class. Okay, just eat something. You need to also take care of your health, right? Okay, so what is the CIP rule? CIP rule means the highest atomic number will get the highest priority, as we have already done that. And the isotopes case, more mass number will get the highest priority. Okay, more mass number will get the highest priority. So now let us see how to define the R and S configuration. Okay, let us see how to define the R and S configuration. So firstly, you have lowest priority group on the vertical position. So he's saying you will you will have this carbon and you will have four groups. Okay, we'll give priority to all these four groups. You will give priority to all these four groups. So now, if the fourth group is on the vertical position, this is actually on the horizontal position. This is the horizontal position. This is the vertical position. So if fourth group, the lowest priority group, okay, I'll write it as fourth group. The fourth group is on the lowest, is on the vertical position. If it is on the vertical position, it is like this. If it is like this, okay, if it is like this, 1, 2, that means this can be varied. This can be varied, but the fourth position is here or here. If it is on the vertical position, then we say for clockwise, we have R configuration, and for anti-clockwise, we have S configuration. Okay, we have anti-clockwise S configuration. Now, for if the lowest priority group is on the horizontal plane, that means you have this carbon and you have this fourth position here, this fourth position here. Now, this means that the clockwise, the roles will be reversed here. The clockwise will be S and the anti-clockwise will be R. And the anti-clockwise will be R. Understood, everyone? If the lowest priority group is on the vertical position, then clockwise R, anti-clockwise S. If it is on the horizontal position, everything will be reversed. R will be converted to S and S will be R. Okay? R will be S and S will be R. Okay? So now let us do some examples. Let us do some examples. This is the first example. All the chiral atoms will only show the RS configuration. Okay? So let us prioritize this. This is the fourth priority group. Priority order will be according to the CIP rule only, right? So this is carbon, this is nitrogen, this is oxygen, right? So this will have okay. So this will have first priority, this will have second priority, this will have third priority, right? So the fourth point is on the horizontal position. This means, now let us see if this is clockwise or anti-clockwise. 1, 2, 3. What is the rotation of 1, 2, 3? 1, 2, 3. That means it is rotating like this. 1, 2, 3. That means it is anti-clockwise. So in case of when you have fourth group on the horizontal, anti-clockwise. Usually anti-clockwise show S when it is vertical position, right? Now it is horizontal. So anti-clockwise will show R. So the answer is R here. So the answer is R. No, the answer will be R. The reason is because you have, whenever you have lowest priority group, fourth group on the horizontal position, then anti-clockwise will show R. Okay, everything will be changed here. Things will be reversed here. Okay, the lowest priority group was on the horizontal position, and on the horizontal position, R is S and S is R. Okay, usually clockwise is R and anti-clockwise is S. But if the lowest priority group is on the horizontal position, R is S and S is R. Okay, that gets reversed. So this the answer is R. So let us do the second question here. Second question here. Now let us see the group is, this is the fourth priority, lowest atomic number, highest atomic number, and this is carbon, this is carbon. This carbon is attached to 3 hydrogens and this carbon is attached to 2 hydrogens and 1 carbon. So this will get highest priority. So this is 1, this is 1, this is 2 and this is 3. Okay, this is 1, this is 2, this is 3 and this is 4. Right? So now let us understand the clockwise or anti-clockwise. This is actually clockwise, right? This is rotating clockwise. Fourth, the lowest priority group is on the vertical position. That means if it is on the vertical position, that means the clockwise will show R. Okay, clockwise will show R. Okay, clockwise will be R. So that is R. Understood everyone? Understood here? Everyone here, are you getting my point? Firstly, write the priority order, then see if the lowest priority group is on the vertical or on the horizontal position. If it is on the vertical position, then what you write here? If it is on the vertical position, then clockwise will be R, anti-clockwise will be S. If it is on the horizontal position, things will be reversed in that case. Okay, so this will be R. This will be R. Okay, this will be R. Now, let us see another. Wow, what a question. What a question. This is a JEE advanced level of question. A very important question. Very, very important question. Okay. So now let us see. Let us prioritize these groups. So now this is carbon, this is carbon, this is carbon, this is carbon. Okay. Let us see what is the priority order of these all. This is a very important question. Let us see. Okay. So firstly I am writing this carbon. This carbon is attached to. This carbon is attached to. I am writing it as A, this is A, this is B, this is C, and this is D. Okay, this is A, this is B, this is C, this is D. And I am talking here A, this is B, this is C, this is D. Okay, so now let us see. For A, the carbon is attached to 1 hydrogen and 2 oxygen. This is double bond. So that means it is attached to 2 oxygens here. That means it is attached to 2 oxygens here. And for B carbon, this is the B carbon. For B carbon, it is attached to 1 oxygen and it is attached to 1 carbon. And 1 valency will be completed by, this carbon has just 3 valencies that are completed here. That means 1 valency is completed by hydrogen. So I am writing 1 hydrogen here. Okay. Now, if we are moving this way, this carbon is attached to 1 oxygen and this oxygen is further attached to 1 carbon. So I write it as carbon. And this way, this carbon is attached to this carbon and this carbon is furtherly attached to this oxygen. So I write it as this. The very nice question. Like it's an amazing question. Okay, it's an amazing question. All the concepts will be cleared here. All the concepts will be cleared here. Okay, now let us see about this C. Okay, till now, do you understand what I have written here? Are you able to understand this? Are you able to understand this? Are you able to understand this? What happened here? Are you able to understand this? Are you able to understand this? Tell me everyone, are you able to understand this or not? Are you able to understand this or not? Everyone in the chat box, everyone in the chat box. Everyone in the chat box, are you able to understand this or not? Rupa, Nancy, are you able to understand this or not? Only then I can move ahead, right? If you're not able to understand this, then what's the point of moving ahead, right? Okay. Then this is B, this carbon is attached to oxygen, I have written that. This oxygen is attached to this carbon, I have written that. This carbon is attached to 1 carbon and then oxygen, 1 carbon and then oxygen. Now let us talk about this carbon atom C. Okay, so for this C, for this carbon is attached to, this C carbon is attached to 2 hydrogens and 1 oxygen. Right, this is actually CH and OH. Right, so this is attached to 1 hydrogen, 1 oxygen. Right. What about this D carbon? What about this D carbon? What about this D carbon? Here, this carbon is attached to 1 oxygen, 1 carbon and carbon. So I'll write it as oxygen, carbon, carbon. Okay? Oxygen, carbon, carbon. This carbon is attached to oxygen, then this oxygen to carbon, this carbon to carbon. Okay? And in this way, it is attached to 1 carbon, carbon and oxygen. So I'll write it as carbon, carbon and oxygen. And what about the vacancy? So this particular, so here also this is just one, also this just one, also 1 carbon here. It's like this. So this carbon is also attached to 1 hydrogen to complete the tetravalency. So here I will write it as 1 hydrogen. So now let us see. Here you have 2 oxygen, 1 hydrogen. Here you have 2, just okay. Let us define the priority. Okay. Here you have 2 hydrogen, 1 oxygen, oxygen. Only C case has 2 hydrogen. That means this will get the lowest priority. Here we will see the priority. Here we will see the priority. Here we will see the priority. This has 2 hydrogen, so this will get the lowest priority. So I'll write C as the lowest priority. C is the lowest priority. That means this is 4th. Right? This is the lowest priority. Now let us see between these. This is oxygen, carbon, hydrogen. This is oxygen, carbon, hydrogen. So that means this is same. Here we have 2 oxygen, 1 hydrogen. That means this will have the highest priority. This will have the highest priority. We have 2 oxygen atom. Wow, we have 2 oxygen atom. Oxygen atom have more atomic number as compared to carbon. So this will be prioritized over this and this. Now let us see between B and D, which will have the highest priority. Between B and D, which will have the highest priority. Let us see. In this case, differentiate from this thing. Differentiate from this thing. Here you have, this is same, this is same. So we can't differentiate on the same basis. Okay. We need a differentiating factor to identify the priority order. Okay, this is same, this is same. OCH, OCH. Now this is CO and this is CC. So this is oxygen. Oxygen is has more priority. This is same. But there is difference of oxygen and carbon. So we will say B has more priority. So this will be 1, 2 and this is 3. Everyone understood this or not? Everyone understood this or not? Everyone understood this or not? Hello. So, understood this or not? Everyone. Okay? So, this we can say that this is 1, 2, 3, 4. And here you will see that the lowest priority group is on the vertical position. That means now we have to identify the clockwise or anti-clockwise order. So this is 1, 2, 3. This is the clockwise order. And the lowest priority group is on the vertical position. That means this is R. This is R. Clockwise means R when the vertical position is of the 4th group. Okay, when the 4th group or lowest priority group is on the vertical position. Okay, everyone? Understood? Perfect. If you are able to solve this kind of question, you can even solve JEE Mains, JEE Advanced kind of question from this topic. Okay, then you don't need to watch any other thing for this R and S configuration. Okay, yes. Now let us see what does this means. How can we actually identify the enantiomer, diastereomers on the basis of R and S configurations? Okay, now let us see that. If both are R, now he is saying from 1 chiral carbon, you don't need to see this. Okay, just I'm saying this. This is 1 chiral atom. This is 1 chiral. Okay. Always remember identical R that are actually overlapping on each other. Right? That are actually superimposable mirror images of each other. I'll write it somewhere. Identical R, superimposable mirror images. And what about enantiomers? And what are enantiomers? Enantiomers are non-superimposable, non-superimposable mirror images. Okay, so like your hands, you have these two hands. They are not superimposable. They are mirror images for each other, but they are not superimposable on each other. Right? They do not hide each other. So that is why they are enantiomers. Right? So what about distereomers? And what about distereomers? Stereomers. And what about distereomers? We'll say they are not mirror images of each other. They are not mirror images of each other. Okay, so these are the three terms that are asked in the exam. Everyone clear on this part? So let us do how to identify identical. Okay. So, yes, RS relation between molecules. Yes. Yeah, you don't need to solve the JEE advanced questions, Diksha. The level is very high, okay? The level is another level, okay? So you don't need to answer, you don't need to solve those questions only. Right? So this is both S, one R and one S. Okay, he's saying if both are R or both are S, then these are identical. If one is R and one is N, that is enantiomer. Okay, so now let us see this. Now if you see this question, let us see if this is the R or S. Okay, so now let us identify this question. Let us identify fluorine, chlorine. Chlorine is number one. Then we will see fluorine. Then we will say deuterium. Then fourth priority will be given to hydrogen. These two are isotopes of each other, and that is why this has highest priority as compared to this hydrogen. And about these two, this has more atomic number. So the priority is 1, 2, 3, 4. As we know, this is actually a 1, 2, 3. That means this is a anti-clockwise order. Anti-clockwise order means, and the lowest priority group is on the vertical position, and this is anti-clockwise. This means that this has S configuration. This has S configuration. Okay, this has S configuration. Yeah. So what about this? This is fluorine, deuterium, this and this. So this is 1, this is 2, this is 3, and this is 4. Right. So here we have 1, 2, 3. We have clockwise order, and the fourth lowest priority group is on the vertical position. So the answer is R here. Right. So what about this? What we can say? The one is R and one is S. That means one is R and one is S. That means they are enantiomers. Okay, so we'll write it as enantiomers. Enantiomers. If you can actually find if the mirror images are non-superimposable, you can directly say these are enantiomers. If they have asked you what is R and what is S, then you have to solve this question. Okay, then you have to solve this question. Okay. So now let us see this. What about this question? Now, as you can see, this is fluorine, chlorine, bromine. So this is number 1, this is number 2, then this is number 3, and this is number 4. Similarly with this is number 1, this is number 1. The priority is number 1, this is number 2, this is number 3, and this is number 4. Right? Okay? Because of the atomic order, I have written the priority order here. Right? Okay? So now, this is 1, 2, 3. That means it is going anti-clockwise. And the lowest priority group is on the 4th position. What does that mean? That means on the 4th position. This means that it will show an opposite order. Anti-clockwise will show R. Anti-clockwise will show R. No, this is anti-clockwise. Right? But anti-clockwise, when we have lowest priority group on the horizontal position, in that case, it will show R. Okay? In that case, it will show R. Okay? And what about this? This is 1, 2, 3. This is also, no, this is clockwise. This is clockwise, but the 4th group is on the vertical position. That means when the 4th group, when the lowest priority group is on the vertical position, then clockwise will show R. Okay? Okay? That will be. So both are identical to each other. Both are identical to each other. You will write it as identical. They are identical to each other. This is R and this is also R. Okay? So these are identical to each other. Okay, so we have completed a century. We have completed 100 slides today. We have completed 100 slides. Very good, bacho. Very good. So now let us see if we have two chiral carbon. If you have two chiral carbon, then what will you do? Okay, so okay. This is chiral, this is chiral, this is chiral, this is chiral. Okay, you can also see that I will not calculate this as such, Abhi. Okay, right now I will not calculate this. I will just tell you one simple trick to that. Very simple to identify this. Okay, you just see, are these mirror images of each other? Yes, these are actually mirror images. If you put a mirror here, these are actually the mirror images of each other. But can we superimpose this on this? These are non-superimposable, non-superimposable, non-superimposable mirror images. So these are basically enantiomers. So these are basically enantiomers. Okay, these are basically enantiomers, right? Okay, but now see one more thing here. Just one more thing here. You just need to see one more thing here. As you know, just calculate this. Just calculate this. If both are opposite, that means I'll just simply tell you this, okay? Because otherwise it will take another like 1 hour. I don't want you to, starve for another 1 hour. So just see this. If both are opposite, that means this is also R and this is S and this is S and this is R. Okay, I'll just write it here. Both opposite means this is R and this is S and this is S and this is R. That means if this is R and this is S and this is S and this is R. Or you say this is S and this is R and this is S and this is R. Okay, so that means both are opposite to each other, right? Or vice versa. So if both are opposite, in that case it will be enantiomer. Okay, if both are same, means this is R and this is also R, this is S and this is also S. Or this is S and this is S and this is R and this is also R. Then this is identical to each other. Okay, these are identical. If one opposite, one same, that this is R and this is S and this is R and this is R. Or you have this is S and this is S, this is R and this is S. Okay, these are the kind of sets that you will have. Okay, understood everyone? If both are opposite to each other, I can actually solve this also. Just let me solve this for you. Otherwise, you will get like, okay, ma'am, we don't know. Please answer this question. Okay, so I will solve this for you. Now you have this first priority, and this carbon will have bromine here. So this will be given second priority. This will be given third priority. This will be given fourth priority here. Right? Similarly, this is first priority, fourth priority. This is second priority. This is third priority. Okay. This is the case here. This is carbon. This carbon will have bromine. This carbon has 3 hydrogens. Right? So the hydrogen, this is actually moving clockwise. But clockwise, this is moving clockwise. So it should have R. But because this is on the horizontal position, so it will have S. So here the configuration is S. Here the configuration is S. And here the configuration will be, what will be the configuration this side? What will be the configuration this side? The configuration here will be, this will be 1, this will be 2, this will be 3, and this will be 4. Okay, so this will be anti-clockwise, this will be anti-clockwise, and horizontal. So anti-clockwise should be S, but this will be R. This will be R because the fourth group is on the horizontal position, so this is R. Okay, so now let us see in this case. Are you able to understand this? Or I am moving too fast for you? Is the speed right, or am I moving too fast for you? Should I slow a little bit down, or should I move with this pace only? Right? Okay, just let me know in the chat box. Okay, this is 1, this is 2, this is 3, this is 4. This is moving anti-clockwise. And for horizontal position, you have anti-clockwise R. Right? So this will be R. So this will be R. Here also it will be R. Write it as R. Okay. So now here it will be, this is 1, this is 2, this is 3, and this is 4. This is actually clockwise, and for clockwise it is R, but in this case it will be S because this is opposite. This will be reversed because lowest priority group is on the horizontal position. Okay. Okay, what I just said. This is clockwise, this should be R, but this is S. Okay, but this is S. Okay, so Now what do you see? This is S, this is R. This is R, this is S. That means both are opposite to each other. Both are opposite. That means this should be an enantiomer. That means this should be an enantiomer. Okay. I have also told you the direct method and the long method for that. Both the methods. Okay. If they have asked you identify R and S, you can do that. If they asked you an enantiomer or what, you can easily do that. If you're not able to find the mirror images and you're not able to understand how to find the mirror images, and that is, they've asked some tricky question, you can always do it by R and S. Okay? Okay, thank you. Okay, perfect. So now let us see the odd and even exchanges. Now, what is odd and even exchanges? Let us find the R and S order of this. Okay, firstly, let us find the R and S order of this. This is the fourth position. This is the first. Fluorine, chlorine, bromine. So this is first, this is second, and this is third. I have done this according to the atomic number, right? So this is first, this is second, and this is third, and this is fourth. Again, this is first, second, third, and fourth. So now let us see the R and S configuration here. Here it is 1, 2, 3. That means anti-clockwise. For anti-clockwise, it will be S. This will be S. And for this, it will be 1, 2, 3. Again, this is anti-clockwise, but this lowest priority group is on the horizontal position. So this will be, this should be S, but this is R. But this is R. Okay? Because lowest priority group is on the horizontal position. Right? And what about this? This is actually 1, 2, 3. This is clockwise. This should be R, but this is S. What is the reason why this is S? Because lowest priority group is on the horizontal position. So this is S. Okay. So now these are the things. This is S, 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 R and S. This is the configuration. Now let us understand what do you mean by even and odd and even exchange. So here, as you can see, this fluorine is on the same position, bromine is on the same position. What I have done, I have flipped this hydrogen and this chlorine. Okay, I have exchanged this position of hydrogen and this chlorine. Okay, I have switched these positions. That means I have done one odd exchange. I have done one odd exchange. One odd exchange, right? So when you are doing one odd exchange, then the configuration flips. R becomes, S becomes R. Okay. So again, what I am doing here, this is the, here chlorine is same, hydrogen is same, but fluorine and bromine are switched here. So this is fluorine is here, and bromine is here. Okay. So that means in this case, again, I have done one odd exchange. Again, I have done one odd exchange, and that is why here R is shifted to S and here S is shifted to R because of one odd exchange. And when we are talking about from going this, if this is A, this is B, if this is A and this is B and this is C. Going from A to B, you have done one odd exchange, hence the inverse of configuration. From B to C also odd exchange, and hence the configuration have reversed, right? But from A to C, you have done 2 odd exchange. That means 1 even exchange. And for even exchange, the configuration is S, and here also S. The configuration is same. Okay, the configuration is same. Understood? Understood, everyone? Understood, everyone? Understood, everyone, or not? Have you understood this or not? Understood? Odd and even exchange. If we're doing odd exchange, there is inverse of configuration. If there is even exchange, there is no inverse of configuration. Okay? Perfect. Perfect. Now let us do this. Let us do this. DL configuration. Let us do the DL configuration. Now for DL, oh my god, Ravan is here. Ravan is here. Wow, very nice. So DL configuration, let us talk about this. For DL configuration is very simple. Very simple. Very simple. It'll just take 5 minutes to understand, to make you understand this. Okay. So if mirror images of bimolecules, oxidized group on the top. Okay. So what is saying? There should be mirror images of each other. I'll let you understand this from the example only. Right. So what are the conditions? How you can identify the D and L configuration here? Okay. So if the OH, the group on the last chiral carbon, Firstly, identify the last chiral carbon. From downwards, identify the last chiral carbon. Last, not last carbon. Last chiral carbon. After identifying the last chiral carbon, just see this one OH group and this one NH2 group. Okay? If the OH group or NH2 group is on the right position, that is D configuration. If OH or NH2 group is on the left position, that is L configuration. Again, doctor. Again, DR. D means right configuration. D means right configuration, right? And it has nothing to do with small n or small l. Nothing to do with that, okay? Nothing to do with that, right? Okay? Okay. So now let us understand this D and L configuration. So this is A part, this is B part. Now, as you can see, this is not the last chiral carbon. This is the last chiral carbon. This is the last chiral carbon. Here also, this is the last. This is the only chiral carbon. What about last? This is the from downwards. This is the last chiral carbon, right? So this chiral carbon has OH on the left side. So this is L configuration. This chiral carbon has OH on the right side. This is D configuration. As simple as that. Very simple. Very simple. Done. Very simple. You know what? It is freezing here. It is actually freezing here. It's, I guess, 6 degrees Celsius that I'm living in. I'm currently living in 6 degrees Celsius. So what is the temperature of your state? What is the temperature in your city? I'm 6 degrees Celsius. My hands are literally freezing right now. Okay. So see, this carbon and this carbon. This carbon is one group, one group. This carbon is last carbon, but this is not a chiral carbon. This is a chiral carbon. So what I'll do, I'll just check this. This is also chiral carbon. This is a last chiral carbon. Though, this is also chiral carbon. This is also chiral carbon. But what I am going to see, the last chiral carbon. Not all the chiral carbon. Just last chiral carbon. Okay. So, seeing this, we have last chiral carbon. So, we'll focus on this carbon and this carbon. Here the OH is on the left side. So, this is L. And here the OH is on the right side. This is D. Okay, you don't need to see any OH of this and this. No, just see the OH of last chiral carbon. This is the last chiral carbon, and here the OH is on the left side, so L, and here the OH is on the right side, so D. Okay, perfect. L and D. Perfect. Next is if they have confused you. Okay, this question will be asked in the exam from DL configuration if they have asked it. Okay, because this is a very simple thing. Like, this is a very simple thing. So what about this thing? This is also very simple. So what you do, if NH2 and OH2, select according to NH2. If you are given a choice that you have in that particular compound, you have OH and as well as NH2. Don't see the last chiral carbon here. Don't see the last chiral carbon here. Don't see the last chiral carbon here. Do not see the last chiral carbon here. Okay? Just see where is the NH2 group. If the NH2 group is on the right side, that means it is the D configuration. Do not see the last chiral carbon. So many students write it as L configuration because they feel that this particular carbon, this is the last chiral carbon and this is on the left side, so this is the L configuration. That is wrong. Okay, you just need to see if you have given a choice, if you have NH2 and OH, both are in that compound, just see where is the NH2 group. If that is on the right side, then it is a D configuration. Okay, perfect. So this is a D configuration. Okay, so this is the D configuration. Everyone understood this? Everyone? 26 degrees Celsius. Oh my God. Wow. I want to be there. I want to come there. Okay. This is actually freezing here. It's actually 5 to 6 degrees. I'm like, oh my God, my hands are literally right now. You can see they're almost red. You can clearly see they're red right now, right? So they're almost like you are, oh my God, what ma'am you're doing to us. Right, so let us switch on the heater. Only that way I can survive here. Otherwise, I will go. Then who will teach you organic chemistry? Okay, so now let us understand epimers. Just 10 to 15 minutes lecture left. Just 10 to 15 minutes lecture is left. Okay, so we will be done with this lecture at 9 o'clock. Okay, 9 o'clock we'll cover this lecture. Okay, so what are epimers? Epimers are if a molecule has more than one chiral atom. If a molecule has more than one chiral atom, and this next line is very important, only one chiral carbon is different. That is called epimer of each other. That means this chiral, this is also chiral, this is also chiral, this is also chiral, this is also chiral, 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 chiral. Right? All these are chiral. Are these two epimers of each other? Let us see. Okay? You will find it very easy if you've done this question. Then you will find it very easy when you will solve the questions of bimolecules. Okay? So let us see. This is OH, this is OH, so same. This is Br, same. Cn, oh my god, you can see a difference here. You can see a difference here. So this particular chiral atom is the differentiating factor here. That means here you can say these are epimers. If you have more than one, what they say? If you have more than one chiral carbons and one of them is different, then that is called epimer of each other. So these two are epimers of each other. Okay, these two are epimers of each other. So when you saying turn off the AC, but how can you turn off the AC of God? I'm living in 5 to 6 degrees Celsius. How can you turn off the AC here? There is no AC. There is no AC. I'm already this is actually AC given by God itself, right? Okay. So now what about anomers? What about anomers? Let us say these are nothing but cyclic epimers. These are cyclic epimers, right? So let us see the structure. Let us see, you will get to see lots of these structures in biomolecules. Okay, so this is the cyclic epimers. Cyclic epimers means, so these all are chiral carbons. These all are chiral carbons, right? These all are chiral carbons, right? Okay. Now let us see, you have more than one chiral carbon, then this is a cyclic structure. So now just we need to see one more thing. Is there any chiral carbon that has opposite groups, right? Like the groups are attached opposite to each other, right? Okay. So OH, 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 H, H. Here to say till now it is same. OH and this is OH. This is CH2. On the top, this is CH2 and this is H. On the down, it is H and here it is CH2. OH. That means, okay, that means this particular carbon is different here. This chiral carbon is different here. So these are anomers of each other. So these are anomers of each other. Understood, everyone? These are anomers of each other. Perfect. Understood? Shall I move ahead? Shall I move ahead or not? Shall I move ahead or not? Shall I move ahead? Everyone in the chat box, is this clear to you? Only then I'll go ahead. No, tell me if this is clear to you or not. Everyone in the chat box. Everyone in the chat box. Okay? Now, what is therio and erythro? What is therio and erythro? Therio means different side and erythro means same side. Okay, same side erythro, different side therio, same side erythro, same side erythro, same side erythro. Okay, just this thing. Okay, now you have these compounds. Now you have chlorine atoms on the same side and you have chlorine atoms on the different side. If in the Fischer projection you have chlorine atoms on the same, if you have groups on the same side, everything else is same. That is called therio. Same side, that is called erythro. That is called erythro. And if the atoms are on the opposite side, on the different side, that will say that is therio. That is called therio. Okay, this is erythro and this is therio. Okay, understood? Yeah, this is the tongue twister. The tongue twister. Last topic of today. Last topic. Okay, my students, now we have completed the isomerism. Everything we have completed. Right, just left with one topic, that is how to calculate optical isomerism. How to calculate optical isomers, right? I'll make you calculate how to calculate stereoisomers when I'll teach you configuration, right? Conformers of ethane and everything. After that, we will discuss about that. Okay. Now, how to calculate optical isomers? Let us see. If you have unsymmetrical, then the formula will be this is optically active. This is mesoisomers, right? This is meso compound. These are optically active compounds. Okay, these are optically active. If they asked you how many optically active isomers, just apply this formula. If they asked you how many meso compounds, then apply this formula. If they have asked you what are the optical isomers, just add optically active and meso compounds. If they have asked you about the racemic mixture, what is this? This is racemic mixture. This is racemic mixture. If they have asked you about the racemic mixture on the enantiomer, then just divide optically active isomer by 2. Okay? Then just divide optically active. My tongue is twisting right now. I'm fumbling right now. It's so much cold here. Okay? So this is optically active divided by 2. Okay? Understood everyone? Understood everyone or not? Everyone in the chat box, have you understood this or not? Let us apply these formulas, okay? Only then you will be able to understand this. What do you mean by N? While calculating the geometrical isomers, N were the number of geometrically isomers sites, okay? The number of double bonds that shows geometrical isomerism. And here, N is the number of chiral carbons. N is the number of chiral carbons, okay? So let us do this. Is this the chiral carbon? Is this the chiral carbon? This is chlorine. This is one hydrogen. This is different, and this is here you met bromine, and here you do not met bromine. So that means this is a chiral carbon. This is the chiral carbon, right? This is a chiral carbon. And in same way, this will also be a chiral carbon. So here the N is 2. N is 2. Is this molecule symmetrical or asymmetrical? This we cannot divide this molecule into 2 equal halves. So this is a symmetrical molecule. So now, if you have a symmetrical molecule, what is the answer? A symmetrical molecule, the answer is 2 raised to power n. The answer is 2 raised to power n. So write optically active isomer will be 2 raised to power 2, that is 4. Meso, there will be no meso here. 0 meso isomers. As you can see it here. In the table only you can see no meso isomer in case of unsymmetrical compound. In case of unsymmetrical compound, no meso isomer is there. Right? So just write it as meso is 2. What about optical isomers? That is optically active plus meso, that is 4 plus 0, that is 4. Right? That is 4 plus 0 is equals to 4. Right? What about enantiomer? What about enantiomer or racemic mixture? That will be optically active divided by 2, that is 4 divided by 2, that is 2. Okay, that is 2. Understood everyone? Will you be able to calculate all of these? Will you be able to calculate all of these? Tell me, will you be able to calculate all of these? Right? Okay? Understood? Understood? Now, let us switch to next question here. Next question here. Is this chiral? Yes, this is chiral. Here, this is bromine and hydrogen, and here you find CH2, here you find Br. Is this chiral? Yes, this is also chiral. But here, N is equals to 2, but this is a symmetrical. It has plane of symmetry. So this is symmetrical. When the compound is symmetrical, and N is even, then you apply 2 raised to power N minus 1. 2 raised to power n by 2 minus 1 for mesoisomer, for optically active isomer. Right? 2 raised to power. Okay. So this is 2 raised to power n minus 1. That is 2 raised to power 2 minus 1. 2 minus 1. That is 2 raised to power 1. That is 2. Right? For mesoisomers, how will you calculate that? For mesoisomer, the formula is 2 raised to power n by 2. N by 2 is 1 minus 1. That is 2 raised to power 0. That is 1. Okay, that is 1. Okay, that is 1. Understood? how to calculate optically active and then mesoisomers. Then after that, just calculate total optical isomer. That will be meso plus optically active. That is 2 plus 1. That is 3. What about racemic mixture or an enantiomer? Racemic mixture or an enantiomer equals to optically active divided by 2. That is 1. That is 1. Okay, everyone? Everyone in the chat box? Is this clear to you? If you're given one symmetrical and this is even number, so calculate this way. Okay? Calculate this way. These are the all questions that you will be asked. Okay? That you will be asked in the exam. Okay? Okay, everyone? Okay, everyone, this is the chart that you need to follow for calculating the optically active isomer, optical isomers, meso compounds, and racemic mixture and enantiomer, everything. Just this thing, and then remember this thing. Optical isomer is equals to optically active plus mesomers. Racemic mixture is equals to optically active divided by 2. Okay? Perfect? Okay, perfect. Perfect. So now, let us calculate the optical isomers in this case. Okay. What new in this case? Here we have pseudo-chiral carbon. Pseudo means that is false. Okay. Pseudo means false. So one chiral carbon. Okay. This is chiral, we all know. One hydrogen, one OH. This group is different. This is different. So this is chiral. This is one hydrogen, one OH. This group is different. This group is, oh ma'am. This group is same. This group is also same. That means this is not chiral. Ma'am, here it will be chiral. But I am saying that this is also chiral. And this is pseudo-chiral. It is pseudo-chiral. I am writing it pseudo-chiral. Why, ma'am, you have written it as pseudo-chiral? What was the emergency of writing it as pseudo-chiral? I will understand. I'll teach you that. Why I have written it as pseudo-chiral. This next concept is pseudo-chiral only. Firstly, just understand this thing. If something is pseudo-chiral, then we include it in calculating the optical isomers. So here, including the pseudo-chiral carbon, the number of chiral carbon sites will be 3. And what is chiral carbon? What is pseudo-chiral carbon? We have two conditions for that. Just wait for 2 minutes. After 2 minutes, you'll be able to understand what is a pseudo-chiral carbon. Just give me 2 minutes, okay? So, this is N is equals to 3. So, for that, this is actually a symmetrical molecule. This is actually symmetrical, right? This is a symmetrical molecule, right? So, this is a symmetrical molecule. For symmetrical molecule and for N is equals to 3, that means odd. What was the case? What was the case for this? Okay, the case was this. 2 raised to power n minus 1 minus n minus 1 by 2. And this thing was the mesoisomer. Okay, this is the chart. Symmetrical or 2 raised to power n minus 1 minus 2 raised to power n minus 1 by 2. And this is the mesoisomer only. Right? Okay, just calculate it here. Just write it here. Okay, just write it here. Okay, just write it here. This is the optically active isomer. How many optically? 2 raised to power n minus 1. This is 3 minus 1, that is 2, minus 2 raised to power n minus 1 by 2. 2 by 2, that is 1. So that is 4 minus 2. That is 4 minus 2, that is 2. Okay, that is 4 minus 2, that is 2. Right? So what about the meso compounds? So meso compounds, how many meso compounds will be here? 2 raised to power 1 is the meso compound. That is 2 is this particular number is the meso compound only. This particular number that we have subtracted from optically active isomer is the meso compound only. Right? Okay. So what about optical isomers? That is 2 plus 2, that is 4. And what about racemic mixture or an enantiomer? That is optically active divided by 2, that is 1. Okay, everyone, that is 2 to 4, 1. Very nice. Clapping for you all. Very nice. Perfect. I'm so happy that you are doing this with full dedication. So happy for you all. So happy. And this hard work is going to pay off. This hard work is going to pay off. You will see that in your results, okay? You will see that in your results. So now, let us see what is the chiral carbon. Let us see what is the chiral carbon. What is the pseudo-chiral carbon, right? Pseudo means false. It means when we see it, it is not chiral, but actually it is a chiral carbon. We do not know if it is chiral or not. So how can it be a chiral and even not a chiral carbon? What does that mean? What are the conditions for that? So now there are two conditions. This is the first condition. This is the first condition. If a carbon is between two chiral carbons, if there are two chiral carbons, if a carbon is stuck between two chiral carbons, then that carbon is pseudo-chiral carbon. Now, what is the reason why a carbon stuck between two chiral carbon is a pseudo-chiral carbon? Let us understand that. Let us understand that. Okay? Right? So now, this is a pseudo-chiral carbon. Why so? Because as you know, this is a chiral carbon. This can be S or this can be R. This can be S or this can be R. Why so, ma'am? Why can't we find the configuration? Why can't we find if this is S or R? Why can't we? The reason is, why can't we find the configuration is because here we don't know where is the H. Whether H is here or here. Whether OH is here or here. We don't know the exact position. Whether H is on the left side or on the right side. So even if we know the priority order, we won't be able to find the R or S configuration for this carbon or for this carbon. So there can be 2-3 possibilities. So first possibility can be that this is R and this is R. Second can be this is R and this is S. Third can be this is S and this is S. Fourth can be this is S and this is R. So in this case, if these both are same, this is same and this is same. In these cases, that will be this chiral, this carbon will not be, this will be achiral. If on both sides, both have same configuration, then the carbon in between this carbon will be achiral. This will be achiral. But if this is opposite, if the configuration is opposite, that will be chiral, that will be chiral. So that means, okay, yes. So that means actually we don't know if this carbon is chiral or not chiral. It totally depends on the arrangement, on the spatial arrangement. Whether this hydrogen is on the left side or on the right side. And that is why we simply say if we have if we have one carbon that is stuck between two chiral carbon, then this carbon is pseudo-chiral. Then this carbon is pseudo-chiral. Understood, everyone? This is the first condition. This is the first condition. Everyone in the chat box, have you understood this thing? Understood this thing? What is a pseudo-chiral carbon? When you have a carbon that is stuck between two chiral carbon atoms, that is a pseudo-chiral. Okay, that is the first condition. Just, yeah. Wait. Yes. So, what is this? I'll come to another also. So, what is this? This is the PYQs. As you all know, PYQs are very important. Now, all these questions, they're actually the analysis of PYQs. Firstly, we go through the PYQs, then we analyze those things. But solving the PYQs yourself is very important, but very important. If you're not solving the PYQs, and right now you don't even have to buy any book. You just need to, this is totally free of cost. Just log in with your email ID, start the test and end the test and see your performance report and the solutions. Everything is available. You don't need to buy any book you don't need to buy. You just need your phone and just log in with your email ID and do your PYQs test, right? That are predicted PYQs. That kind of questions will be asked in that PYQ test. And after that, I am telling you, there will be a proper revision. After this thing, you are going to solve the PYQs of isomerism, okay? After this session, you are going to solve the PYQs of isomerism, okay? Okay. So about the Telegram quiz, as you all know, every day Telegram quiz happens. Every day, what you do, just go to the link on the Telegram quiz link, then start, and then I'm ready, and you have your scorecard and rank. You can actually identify among all the students where you rank, where you need to, improve yourself. What are your weaknesses? And this is also totally free of cost. Nobody is charging you for this. So just need to click the link. Okay, you just need to click the link. After the class, I'll also mention how to click the link and how to start the test. Okay, I just want one thing from you. Do a thing today itself. Today, do the PYQs of GOC plus isomerism. Do the PYQs of these two things. Okay, if you're not able to open it, I'll teach you in the next class, but do try it. Okay, I'm going to ask you this in the next lecture, if you have done the PYQs or not. Okay, I also saw this Telegram quiz. Everything is mentioned in the Telegram channel. Okay, just go to the Telegram and see. The link will be mentioned in the description. Just go to the Telegram. Everything is provided. As I already told you, PDFs, everything is provided in the Telegram itself. Right? Okay. Tell me, everyone in the chat box, will you do that or not? Everyone in the chat box, will you do that or not? Can I expect PYQ session? If I'm standing here for last 4 hours, can I expect that you do your PYQ session? Can I expect that from you? Nobody is asking you to buy any book. Nobody is asking you to buy any course. This is totally free of cost. So you need to do that for yourself, right? Can I expect that from you? Yes? Okay, perfect. Now, what is the second condition of pseudo-chiral carbon? That is, if you have a carbon and there is this double bond here, there is this double bond here, right? Okay. So now this is the CH3. This is H. Okay. CH. Okay. CH. Just a minute. This is CH and this is CH2. Okay. Now, just see this. Just see this question. Okay. Now, if a carbon is stuck between two carbon atoms that have double bond is here, double bond is here, right? And this carbon will be pseudo-carbon. What is the reason? Why this is a pseudo-chiral carbon? The reason behind it is that, very simple reason. The reason behind it is that because this carbon can be cis or it can be trans. We don't know, because we don't know where is H and where is this. How can we say this is cis or trans? If H is on this side, this will be a trans. If H is on this side, this will be a cis, right? We also don't know if this is a cis or a trans, right? And that is why there can be 2-3 combination, that one is cis, another is cis, one is trans, another is trans, one is cis, another is trans, one is trans, another is cis. So if both are cis or both are trans, that is achiral. That is achiral. If one is cis, one is trans, that is chiral. That is chiral. Okay, that means we don't know if this is chiral or achiral. So we can say this is a pseudo-chiral. So we can say this is pseudo-chiral. Understood, everyone? Everyone understood? Everyone in the chat box, now we have completed 4 hours of study, right? So congratulations, everyone. You have completed today's task. Now you just need to do what you need to do tomorrow. I just expect this one thing from you. Do test yourself also. Okay, you give your mock test, weekly test, everything. But right now, right after this chapter, you have completed GOC, you have completed stability. Everything will be asked, and also the syllabus for weekly test. For the weekly test that is going to happen, the syllabus for that will be that isomerism will also be included, optical isomerism will also be included, right? Everything that I have taught this particular week, everything will come in the session, okay, in the mock test, right? Just expect one thing from you, that is actually, I don't want you to just memorize things. I have done my part. I just expect one thing from you. And if you're not doing this now, you're lagging behind. I'm telling you, as your elder sister, right? I'm telling you this, right? Because this is very important. If you're not solving NCRT questions, if you're not doing PYQs, everything else is waste of time. Then also don't attend the classes, right? So I'm just don't after this lecture, after all the GOC that I have completed, you don't need to watch any video. You don't need to again revise this again and again. Just see your notes and revise yourself. Okay, that is like that is overall that was needed for you. But one thing that you must do is practice and practice, lots of practice. So that is why I'm saying, for practicing, if you are practicing PYQs at least 4 to 5 times, at least 4 to 5 times, always write down. You will also get this report card, performance report. You will have a record of how many questions you have solved incorrectly. You will try to understand your weaknesses. What are your weaknesses? Why I am saying all this? I'm just saying all this. I don't want you have studied for 4 hours. That is a big task. I'm so happy for you. I'm so proud of you. All I want you is attend this quiz, okay? For GUC, for isomerism, otherwise you will forget everything that is taught in this class, okay? Just revise this. Tomorrow you have time. We have our class. We will have our class, I guess, on Monday. Okay, on Monday we are going to do test analysis. Okay, this weekly test is going to be very important. Why? The reason is all teachers are going to do the test analysis of this weekly test that is going to happen this Sunday, right? So that is why this test becomes a very important test for you, because your teachers will analyze that test for you, right? So that is why I am going to meet you on Monday after this class, right? So that is why I'm saying you have so many days in between. What you do? Revise this. PYQs. Solve this quiz. Understand what are your weaknesses. Everyone in the chat box, will you do? Everyone in the chat box. Very good evening. But now I'm going. Yeah, I'll make another video for that, like conversion of all those things, right? I'll make another video of that. Just tell me that. Will you do that? Everyone in the chat box. Yes, ma'am. Yes, ma'am. That's your promise to me. That's your promise to me. Okay. So that is your homework. Do the PYQs. And I'll check these comments. I'll definitely check these comments. You have time till Sunday. Till Sunday you have time. Till Sunday, do the PYQs of stability of intermediate, acidic basic strength, everything, electron displacement, geometrical isomerism, optical isomerism, everything. Do the PYQs that have been asked from this, right? And also test yourself. Test yourself. You have everything that is on the portal. Everything is on the portal, and that is totally free of cost, right? Totally free of cost. You have been provided so many things. Take advantage of it. Take advantage of it. Okay, and trust me on this. Okay. So till Sunday you have time. Till now, what all we have completed, just do one thing, test yourself, and once you are done with the PYQs, once you have done the PYQs based on this, just write in the comment section of this video. Okay. Once you are done with the PYQs, I am monitoring you here. Just just switch on this link. Okay, just go to this link and write down in the comment section that, ma'am, we have done the PYQs of GOC and isomerism. I'll be so happy. Okay, and I'll also check if you have done that or not. Okay, just submit your email ID. I'll check if you have done that or not. In that way, I can even monitor you if you have done that or not. Okay, perfect. Yes, everyone, I'm going to wait. I'm going to see how many of you have answered. How many of you have commented till Sunday that you have completed the PYQs till now? I'll be so happy. I'll feel like, okay, these students are also very energetic. If I'm putting my 100%, they're also putting their 100%. Okay, perfect. Okay then, bye-bye. Take care. Have your dinner. Relax for a bit. Now just take rest for 1 hour. Just relax or go to sleep after dinner, and early morning wake up. And if you want to study late night, just take 1 and 1.5 break and revise these notes. I'll send you these notes, and after that, with a fresh mind, start physics or biology. Now, today for your chemistry part is done. Okay then, bye bye. Take care. Have a sound sleep. See you all tomorrow. See you all on Monday. Bye bye.